Hello.
हेलो सर।
ओ, क्या
स्टार्ट करना है।
जस्ट उनको जस्ट अंदर लिया है ना,
उनको बस बोल रहे हैं 10 मिनट से स्टार्ट
हम
करना
10 मिनट में सेशन
7-8 मिनट्स में स्टार्ट करना
उनको जस्ट एक सेकंड सर, किधर गए सर? वी विल स्टार्ट द सेशन इन 10 मिनट्स सर।
क्या कुछ प्रॉब्लम है क्या? इज देयर एनी इशू?
हाँ सर, वो जजेस है उनका जस्ट वो हाँ अरेंजमेंट जस्ट हो रहा है जो
अच्छा
नेक्स्ट रूम में है ना। हाँ, सो जस्ट 5 मिनट्स मोर, लाइक इट विल टेक 5 more minutes।
ओके. द
तो
अदर जजेस नखाते एंड सावरीज आर अराउंड ना?
हाँ हाँ, वो है सर, उनका जस्ट जो ये है ना लॉगिन जो है
अच्छा
वो चल रहा है सर।
अच्छा, मैं आपको पहचान नहीं. संदीप.
रूशल सर, रूशल।
अच्छा, रूशल रूशल, हाँ रूश, ठीक है. हु विल बी कंट्रोलिंग देयर द पार्टिसिपेंट्स?
आई एम डूइंग दैट सर।
अच्छा, यू आर डूइंग दैट नहीं.
हाँ
तो
हाँ,
वी विल ट्राई टू मेंटेन दैट 3+2 5 minutes नहीं,
यस यस
है
यस
ना?
सर।
सो
So we will ring this bell. We will
ओके
ring this bell. Yes.
ओके
After 3 minutes,
ओके.
you are able to hear, na sir?
राइट, आई एम एबल टू
Yes.
हियर.
Yes.
सो यू
Yes.
आर एबल टू हियर मी ना?
Yes. Yes.
बस
Perfect. Yeah.
ठीक है, हाँ हाँ.
ठीक है sir. So we
ओके.
will start the session in 5 more minutes, sir.
नो प्रॉब्लम, नो प्रॉब्लम.
Okay. Okay, sir. Okay. Uh, we will start in few more minutes.
No.
Please stay online.
1195 आया है ना?
So good afternoon, sir.
Thank you. Good afternoon. Had they come, Sabri, I wanted to communicate with them.
हाँ sir,
Sabri and
actually what,
Nakhate.
हाँ they all have came. Nakhate sir and Aswari madam has came. So
Okay.
laptop is मतलब is getting set up.
Okay. Okay. No problem.
So maybe 2-3 minutes more.
No problem. No issue.
Okay sir, thank you.
Hmm. So, Rushal, when a person making a presentation, at somewhere his name should also be there, na?
Yes sir. Sir,
And,
actually at the starting na I will
uh-huh.
speak out the person's name and the
Okay.
paper number, the poster
Okay.
number.
That CP number, hai na?
हाँ CP number sir.
Okay. If you start, I mean, 9, you need not to say 1, 2, 3, 4 like that, na? That we know it is connected only CP9.
Yes 29.
But I'm telling this section is 9, CP9. That
Yes sir, yes.
yeah. So it 1 to 29, hai na?
Yes sir, yes.
Okay. Okay.
So we will try to bring all the presenters sequentially, but
Okay.
if in case somebody is not there,
Okay.
then they may be taken up at the last.
Right.
So that's why I will call out the paper number and the person's name,
Okay.
so that you can be mark them accordingly.
See, I do not have that abstract list with me.
किसके नाम कौन है?
Okay, okay.
I mean, otherwise I have to open my mobile. It is there.
Sir, no need. You just
Ah,
take one your notebook and we will read out the poster's name. So accordingly you
okay.
can give them marks. Accordingly.
Yeah, yeah.
Okay, sir.
You just tell the name and I have noted down number 1, 2, 3.
Yes, sir. Yes. Okay.
सेंड करता हूँ पर इनको चालू करिए
They have to actually be upgraded. Yeah, he's come.
मैडम तुम्ही ना कॅमेरा ऑनच ठेवा
हो honest ठेवणार काय
Asavari madam, can you hear us?
Yes, very clearly.
Okay, okay, madam. And
Hello. Hello, Padma.
Sir. So after this meeting is over, na, you will only have to among yourselves decide something. Every
Okay.
committee is going to decide like that, and they
Okay.
will contact you with their 1, 2, 3 numbers or something like that. So
Okay.
on the last, so
How
you will have
many? How many? What we are going to give, or how many posters you want us to list?
that Ila will decide. But depending on your number, suppose you have 30, you can at least take 3 or 4.
3. Okay. Okay.
3 or 4. But you can list and you can ask Ila people what they want.
Okay. 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 Okay.
so Asavari madam, shall we start? Everything is ready with you?
Yes,
And
yes.
Hi, hello.
hello, Nikhate.
Hi. Yeah,
So you are there, ni?
yeah.
Anyway, I don't have to bear this because I am sitting alone in my room.
I could have also, but then I thought I will give company to Asavari.
Yeah.
So I am here.
So Nakhate and Asabri, we will stick to the timing, ni, because already we have 30 posters, ni. So otherwise it is going to run very long, ni. So we'll try to stick to the time.
Sorry.
So
Few questions.
the session management people, they will be keeping the time. So
Yeah.
Mr. Sandeep, please note this.
ठीक है.
So let us start today's poster session.
Okay.
Okay, so welcome you all, and we will start our today's oral poster session. So I kindly request to all the presenters to be online from 1330 hours to 1600 hours. So if someone is not present, then we can move to the next presenter, and his or her name will be taken up at the end. And some of the rules, like you have 3 minutes to present. So you have 3 minutes to complete your presentation. After 2 minutes, first bell will ring to alert you to quickly wind up your presentation in next 1 minute. So at the end of 3 minutes, there will be one more bell, and afterwards the judges will take over for the question answers. So today we'll start with CP 0901. Okay. So what? So we will start with Surendra Singh from RRCAT, and his paper number is CP 0904 03. Sorry.
What happened to first two?
Sir, they are not available right now.
Acha. So 04.
No, sir, 3.
03. Okay.
Surendra Singh RRCAT. Mr. Surendra, can you hear us?
Yeah, I can hear you.
Okay. So,
I think we can start, ne?
your poster will be visible right now, and you can start now.
Okay.
Should I start now? Good afternoon, everyone. I am Suren Singh, working at RRCAT Indore. My work is on atom fountain of rubidium atom with moving optical molasses. This is basically in line with the development of cold atom gravimeter setup for precision measurement of gravitational acceleration G. The introduction is as follows. The laser-cooled rubidium-87 atom in a magneto-optical trap have been launched in vertical geometry using moving optical molasses technique to make an atomic fountain. This cold atom gravimeter setup is basically having configuration of atomic fountain in which cold atoms are launched in the upward direction, and the Raman interferometry is performed to have the phase detection to finally evaluate the value of G. The typical configuration of magno-optical trap is 6-beam configuration in presence of inhomogeneous magno-optical trap, in which we normally get the atom of the temperature of the atom of the order of around the hundreds of microkelvin, and number of atoms are normally 10 to the 6 to 10 to the 7 atoms. Then launch velocity of the relative shift in the frequency. Sorry, I'm not able to see the slide. Hello?
Just a second. I will bring in again.
Yeah. Okay. The launch velocity of the we have basically estimated the launch velocity of the atom by changing the relative shift in the frequency of the cooling laser beams. And then as we have observed a significant atom flux at a distance of around 9 centimeters from the mode center, which is the center of the cold atom source. Then this atom fountain will be used for
The sound is not very clear.
precision measurement of hello. I'm not audible properly. The atom
The
fountain
sound is
will,
not very clear.
is it now clear? Am I audible to all of you?
Yeah.
Not,
Okay, you speak.
that the fountain will be used for precision measurement of Earth gravitational acceleration g value. Is it okay?
Yeah.
Yeah. Next slide, please. This is the experimental setup of our setup in our laboratory.
Just a moment, Dr. Surendra Singh.
Yeah.
Web and session management, we cannot see the slides. First, इसमें होता है problem.
We are not able to see slides.
Okay, sir. Our web team is coming.
For this particular talk, the time will again restart. No? Please note that.
Yes,
Okay,
yes.
okay, ma'am.
This time will not be counted.
Stop. Correct.
Sorry for the inconvenience. I think it will take 2-3 minutes, so please bear with us.
We are able to say now you can start it, I think.
Okay, okay. So, Mr. Surendra, please start.
Can we start from the first slide, please?
First slides. First.
Good afternoon, everyone. Myself is Suren Singh, working at RRCAT Indore. My work is on atomic fountain of rubidium atom with moving optical analysis. This work is in line with the development of cold atom gravimeter setup at RRCAT for high precision measurement of gravitational acceleration value of G. The introduction is as follows. The laser-cooled rubidium atom in a magneto-optical trap has been launched in vertical geometry using moving optical molasses technique to make an atomic fountain. Our CAG setup, gravimeter setup, is basically based on the atomic fountain configuration in which cold atoms are launched upward and the Raman interferometry is performed to have a phase factor due to the Earth's gravitational field. The launch velocity for relative shift of frequency of the cooling laser beam has been estimated by probe absorption technique, which is probe is being passed at a distance of around 9 centimeters from the cold atom source, and the probe absorption is measured. We have also a significant atomic flux has been observed up to a height of 9 centimeters, which is basically evident from the probe absorption signal. This atomic fountain will be used for precision measurement of Earth gravitational acceleration G to a high precision value of the order of delta G, where G is equal to 10 to minus 8 value. Can we go to second slide, please? The experimental setup is as follow. This is a magneto trap configuration in which 6 beams are going from top to bottom, and oppositely same three beams are going from bottom to top. They are all interacting to a center point in presence of a magnetic field. Here we get the slowing of the atom, and atoms are trapped at the center. The typical temperature of the atom at this here is around 250 microkelvin, and the number of atoms are normally 10 to the 7 to 10 to the 6 to 10 to the 7 atoms. When the magnetic field is switched off and these 3 beams are detuned with respect to three beams, these 3 beams atom get forced in the upper directions. So these cold atoms move toward the upper directions, and while moving up, we pass a probe beam at around 9 centimeters from this cold atom source. When the atom interact with this, they get a probe absorption signal on the photodiode, and this single basic arrival of the atoms at this probe, which is at a fixed distance from the cold atom source, provides us the time of arrival of the atom. From there, we can estimate the velocity of the atom, initial velocity of the atom. Okay, this is the actual photograph of the CAG setup, which is basically mode setup. This SS chamber is at around the 10 to minus 10 torr vacuum, where you can see there are different large number of viewports. So 3 beams are passed from this upper 3 viewports, and the counter-propagating 3 beams are passed from lower 3 viewports, and there is CCTV camera, other optical elements. There we can see there is one more glass chamber kept here. Okay. The atoms are basically probed in this glass chamber. So depending upon the distance from the source, we can get the arrival time of the atom at this probe center. Can we go to third slide, please? Third slide. Okay. These are some of the results that we have observed in the probe absorption. We can see there are different detuning. Like for example, this detuning is around 8 megahertz. The detuning is between the upper and lower 3 beam configuration. So this basically tells us that the arrival of the probe at a distance of 9 centimeters. When the detuning is around 8 megahertz, we get a slower atom, and they get
Dr. Surendra, please try to wind up fast.
Okay. When we got at higher detuning, the atoms are faster, and the arrival time is even lower. So at this, it is 7.5 megahertz, it's 7.5 millisecond, and here it is around 7.9 millisecond. So these are the estimations that we have calculated the launch velocity. 8 megahertz is around 10.5 millimeter per second, and at around 16 megahertz is around 12 millimeter per second. We can summarize the atomic fountain for cold atom rubidium 87 atom has been developed and characterized. The launch velocity for atom are measured as a function of relative detuning. The observed height of the fountain is around is more than 9 centimeters from the Moore center, and the further work is in progress. We basically want to have the atom to a larger height for more interaction time. Thank you very much.
Mr. Surinder, I will ask you 2 questions. One
Yes,
is a simple question. I mean, why do you choose rubidium? Why not cesium for this type of study?
Yeah, we can choose cesium also. There is no difference. Basically, we must have the laser source for that. At present, we are working on laser cooling of rubidium 87 only. So we have all the sources corresponding to it is rubidium 87 only, 780 nanometer.
And second question is that you want to measure the gravitational acceleration.
Yes, sir.
How it will be manifested in your measurement? I mean, what exactly you are going to measure, which can tell you what is the.
Yeah, basically we will measure the phase difference, phase incorporated in the atom wave packets because of the gravitational acceleration. We will basically split the atom in two packets. They will get interfered, and during interference they will be impacted by the gravitational acceleration, and from there we can get the estimation of G value.
Okay. Nakhate Sabri, if few people can ask. Dr. Nakhate?
You go in this optical molasses. What is the temperature you got?
Yeah, right now the temperature is around 250 microkelvin.
15 microkelvin. You plan to measure this gravitational G on the Earth, basically surface, yeah? So is it a variable quantity in the from the place to place?
Yeah, it basically depends on the subsurface content, whether it is density of the subsurface material. Like
we are not able to hear you.
Yeah, it differs from place to place to the third, to the seventh or eighth place of the decimal. It depends on the density content under the subsurface content.
Yeah. Then what is the precision of your measurement? That's what I would like to know.
Actually, right now we are not in a position to measure a G. We are in the process to develop the system. We are planning to measure it up to 50 microgal, which is equivalent to 15 to 10 to the minus 8 meter per second square.
Okay, what is the ultimate goal for this basically? Why you want to measure the gravitation G with such a precision?
This is basically for mineral exploration, natural mineral exploration.
Okay.
To know what is the content, whether we can go for oil field or we can go for other kind of power.
Density of the crust you would like to measure by measuring this G.
Yes, sir.
So this sensitivity, you hope that it is sufficient, right?
Yeah, it is sufficient. People have measured the changes.
Okay.
We can go to the next.
Okay. Yeah. Was the answer?
Okay, thank you. Sabri, you want to ask any question?
We are through. We can go to the next.
Thank you, Mr. Sundar Singh. Next person.
Okay, so our next presenter is Mrs. Sunita Gupta from BRC. Sorry, Anita Gupta from BRC, and the poster number is CP0902. Miss Anita, can you hear us?
Yes. Shall I share my slide or you will be sharing?
Yes. Can you see it now? So you can start, huh?
Okay, thank you. Good morning. Hi, I'm Anita Gupta from BARC AMPD. So here I am presenting a HF remote monitor for hydrogen fluoride. This monitor is required in nuclear industries because in here we are using large amount of hydrogen fluoride, and a small leak of hydrogen fluoride can lead to a disastrous event. So currently electrochemical sensors are being used. These sensors have limited lifetime of operation and require periodic calibration. So we want to make another kind of detector which is based on laser absorption spectroscopy, and it can detect hydrogen fluoride in open air path. Next slide, please. So this is the experimental setup. Here we have a laser which is mounted in front of a telescope. The laser beam is shined toward a retroreflector from where it is reflected back to the telescope, and the signal is detected. This detected signal will contain the absorption signal from the hydrogen fluoride atoms, molecules which are present in the atmosphere. So for our studies, we have used both the techniques, direct absorption spectroscopy as well as wavelength modulation spectroscopy. Next slide. So these are the results. Actually, for our experiments, We have kept the hydrogen fluoride in a cell made of Teflon of length 20 centimeter, and we have observed the hydrogen fluoride concentration inside the cell. We filled the cell by putting few drops of hydrogen fluoride. It evaporated, and some part of it was leaking. So signal was measured for 20 days, and we saw an exponential decay. At the last day, we could measure the concentration of around 27 ppm with precision of 5 ppm. And with this sensitivity, using both the direct absorption and WMS technique. So because the sensitivity is same, we decided to use direct absorption spectroscopy only. And with this sensitivity, if we can give a path length of 10 meter, then we can detect less than 0.5 ppm of hydrogen fluoride, which is sufficient to detect the minor leaks and ensure the safety in the system, in the plant. So that's all.
Anita, could you please tell me, you have used these two techniques, direct absorption?
Yes, sir.
And wavelength modulation, this thing.
Yes,
as
sir.
I understand, which one is the more accurate one?
Sir, both are accuracy for both are same. Even
Detection
sensitivity.
limit, as far as the detection limit is concerned.
Sir, both are same. Because in both the techniques, we found that it is limited by the intensity noise in the laser beam, which is due to the long path it is traveling due to some particles or something other, which is causing interaction. So in both the cases, sensitivity was same for our case.
But in wavelength modulation, don't you think that it can overcome the noise of the laser noise?
Sir, it can overcome laser noise, but in this case, the major noise was not the laser noise. It was the noise which was induced in the path, means due to the particles, means uh, uh, suspended particles which are there in the path. They are causing the variations. So that noise was much more than the laser noise. That's why the sensitivity in both the cases were same.
Okay. Savri Nakhate, you want to?
Yes, so what is the path length here you are talking about? Is a multi-path or is a single path?
Sir, in the lab, I could create a path length of 8 meter only. But my sample was in 20 centimeter cell. If we go to a plant
For this particular HF, I am asking for this particular HF experiment.
20 centimeter cell.
20 centimeter. Okay. What is the ground state of the HF? Electronic ground state?
Electronic ground state. Sir, I don't remember the configuration as such.
HF, no, it must be quite because ground state frequency you are measuring only, right?
Yes, sir. It is means it is a transition at 1284 nanometer.
This is the fundamental frequency you are measuring, the first one?
No, sir.
Which transition you are measuring?
It is
Which
not
transition?
fundamental. It is not fundamental frequency. It is second
0 to 1, huh? 0 to 1.
No, sir. It is second harmonic, 0 to 2.
Huh?
0 to 2.
It's not second harmonic. It's basically a overtone band. Yeah. Okay. 0 to 2 you are measuring.
Yes, sir.
I suppose the ground state must be singlet sigma, I think, probably for HF.
Sir, I don't know.
Yeah, it has to be. Then how do you plan to reduce this, increase the sensitivity by some other technique you planning, or just it's a very crude technique to measure the concentration by just absorption? It's a simple absorption.
Yes, sir.
Anything more sensitive techniques? You're
No,
planning?
sir. We want to make it a portable instrument, so we don't want to make it a complicated one. So we are planning to means have more rigorous signal processing, so that sensitivity is little better.
Absorption cross sections are good here in the 0 to 2 or 0 to 1 should be okay.
Sir, it is not that good. Like it is for fundamental.
0 to 1 should be much more, I think, probably.
But for fundamental, there are no compact lasers which are available.
Okay.
Okay, suppose first of all, why hydrogen fluoride? And second question is, if you want to change from hydrogen fluoride to say other atmospheric gases like carbon monoxide, what changes you will have to do in your system?
Hydrogen fluoride we have chosen because it has an application in our department, that is in nuclear fuel processing. And for other gases, we have to change the laser wavelength and means choose a proper absorption line where we can get the signal, interference-free signal.
Yeah, thank you.
Thank you, Anita.
Let's
Go to the next
let's
one.
move to the next presenter, Mr. Salahuddin Khan from RRCAT, and the poster number is CP0901. Mr. Salahuddin, please start.
Good afternoon, everybody. Today's presentation talk is on the micro photoluminescence studies on MOS to 2D monolayer using CW as well as photo femtosecond lasers. So in this study, generally we did some experiments on the transition metal dichalcogenides like MOS2 because transition metal dichalcogenides have attracting properties, optical as well as the electrical properties because of their band gap structure. And in monolayer of these TMDCs, due to the 2D confinement, excitons are formed. That's why there are various applications in the optoelectronic devices. MOS2 is one of this material which have PL signal at room temperature, nearly at 1.82 electron volt. And MOS2 have also two degenerate bellies at different momentums. That's why they can be used as in spintronics and bellytronics devices or in quantum technology applications. So in the present this work we have measured the PL from a single flake of 20 micron size by using the micro PL setup for sample characterization. Basically, we will study to carrier dynamics on this type of monolayer, MOS to monolayer, by using the probe setup. So before that, we have to characterize the sample by measuring the PL signal. And after that, we will also in pump probe study, we measure the coherence signal by using this 2D monolayer materials. Please, next slide. So this is the PL micro PL measurement setup, and here white light is used to image the micron size of the flake, generally 20 microns to 30 micron, and we image on that CCD camera, and after that imaging we incident the 400 nanometer wavelength femtosecond as well as the CW laser, and we measure the PL by using this setup. And finally, please next slide. So by using the CW laser, we have got this type of PL intensity with wavelength and nearly 680 to 680 nanometers. We have observed a strong PL, and the study was done at different intensities, and shows that at different intensities the PL integrated PL was linearly observed. It means it due to the some excitonic nature. And the same experiment was done at 1.7 milliwatt femtosecond laser and compared with the CW laser, and it was observed that during the CW laser the peak shift is nearly 2 nanometer in the red side. So this is the mainly characterization for the small monolayer 2D samples. And after that hello. This is okay. Now I have already done. We have observed 2 nanometer. This is due to the band gap renormalization or sample heating. We will confirm in the further experimental detail.
Hello, is it over?
Yes, it is.
Hello, Mr. Salahuddin. You said that when you have used the CW laser and the pulse laser, you found a shift of 2 nanometer, isn't it?
Yes, sir.
Fluorescence.
Yes, sir.
What does it signify?
What does this change? This may be changed in the band gap.
In the how much it if you what is the exact band gap in this particular this monolayer you are using?
This nearly 1.8 electron volt.
And then this 2 nanometer, how much significance for that as compared to the 1.8 electron volt?
This is not for that regarding PL, but if we measure the current some carrier dynamics study, we don't want to apply the higher excitation intensity. that will change that band gap. So we have to kept in excited intensity lower that the value which were already observed at nearly 1.7 milliwatt.
Okay. Sabri Nakhate. Nakhate? Nakhate, Sabri, anybody want to ask question?
What is the temperature change you expect from CW, from going to CW to femtosecond? Since you are telling that this is due to temperature change, the band gap.
No, sir, this is not yes, maybe this may be due to the temperature change, or this may be due to the band gap renormalization. This will be confirmed by doing some other experiments also.
Renormalization means what you mean to say? Band gap renormalization?
Renormalization means after excited a particular more than particular intensity, the band gap changes.
Okay, this is not because of temperature.
Not because of temperature, just because of the incident intensity.
What is the lifetime of the?
No. You. Hello, Nakhate, just a minute. You only said in the beginning because the temperature has changed in the pulse laser. That is why the band gap has changed.
No, due to temperature, band gap is also changed, but due to the excitation intensity, band gap is also changed.
No, the reason is not deciphered yet.
Yeah. Okay.
Yeah. And what is the lifetime of the exciton you expect there? Basically, you are getting the PL, right? Total luminescence. So have you estimated or found out the lifetime of this state?
No, now we are, but literature shows that this is this is nearly 10 picoseconds nearly.
10 picosecond lifetime. Then why do you call the luminescence here?
Because in the monolayer,
no, the luminescence
very
is
less.
Luminescence terminology for the. There is a difference between luminescence and fluorescence, right?
Yes. But
So why do you call
the
it as a
small
luminescence?
thickness, nearly one monolayer, nearly less than 1 nanometer thickness, the electron and holes confined in that. That's why excitons are formed. That's PL. Due to that confinement of excitons, PL will observe.
It's very fast, right? Yeah. Okay.
Okay, thank you, sir.
We can go to next presenter.
Okay. So before we move to next, I request all the presenters and also to judges, we have to stick the time schedule because we are very tight over the time schedule. So I hope everybody will take care of it.
Yeah.
And so next presenter is Saptasri, and the poster number is CP0906. 04, sorry, CP0904.
Yes. Hello, can you hear me?
Yes,
Hello?
continue.
Okay. Good afternoon. I am Saptarshi from LNPTD BRC. So my topic is optical pumping in uncoated and anti-relaxation coated atomic cell. So optical pumping of atomic populations in a glass cell with various coating is one of the preferred tools of research involving study of atomic dynamics, interacting systems, quantum devices, etc. Here the population dynamics in different hyperfine levels of rubidium atoms is studied with uncoated as well as this OTS coated anti-relaxation cell. We find the subdoppler features of the absorption spectrum in the uncoated cell gets washed out in the OTS coated ARC cell due to enhanced elastic collision cross-section of rubidium atoms with the coating generated background gas as compared to the hyperfine So as compared to the hyperfine changing inelastic collision cross-section between the rubidium atoms themselves, thus makes this coating suitable for applications where longer state preservation is needed. So here the hyperfine energy levels of rubidium-85 atoms is shown. Next slide, please. So in the experiment, the pump beam was locked at the D2 transition of rubidium hyperfine levels around 780 nanometer, and the probe beam was scanned across the D1 transition, which is around the 794 nanometer. The experiments were done with uncoated cell for overlapped and separated configurations of pump and probe beams, and with the OTS coated ARC cell in only overlapped configuration. These were compared with the spectrum where no pump beam is present. So the spatial separation between the beam was 8 millimeter, with each beam having the diameter of 4 millimeter. Both the cell used have diameter of 25 millimeter, length 50 millimeter, and was at 25 degree centigrade of temperature. This is the schematic of the experimental setup. Next slide. Yeah, so the result is so the absorption spectrum for the uncoated cell in the overlap beam configuration, it shows sharp subdoppler features because there is a transfer of population of the zero velocity group of atoms from one hyperfine ground state to other, resulting increased transparency in one transition and decreased transparency in the other. And these features, they get washed out, they are absent when spatially separated beams are used, owing to the fact that in the later case, optically pumped atoms now get sufficient time to thermalize and attain equilibrium Maxwell distribution before interacting with the probe beam. Therefore, we get a smooth absorption spectrum. Now, interestingly, OTS coated ARC cell also shows a similar spectrum with no sharp feature even in the overlap configuration. So this implies, in contrast to the uncoated cell, the coating generated background gas increases the elastic collision cross-section manifold than the hyperfine changing inelastic collision cross-section, thereby making it suitable for applications where longer state preservation is required, that is, experiments involving quantum memory, study of quantum entanglement, atomic devices, etc. One future direction of this work would be to make theoretical models of population dynamics and extract out various parameters involving different collision mechanism and optical pumping responses present by matching with the experimental data. That's it. Thank you.
Hello. Yeah, Saptarshi, you have said that that there's a when you separated those pump and probe beam, nee?
Yes.
And then there's a disappearance of those features, isn't it?
Right.
And what does that signify, and how much separation you have to do when you start observing that disappearing of those features?
So the separation, I think it's written in the this thing. Yeah. So the spatial separation between the beam was 8 millimeter. And the reason, so the first thing is that why we see the subdoppler features. So we see the subdoppler features because due to optical pumping, the zero velocity group of atoms, they get transferred from one hyperfine ground state to another. So when I scan across the D2 transition, so in one level we see decreased transparency, and one level we see more absorption, and other level we see less absorption. So that is the reason why we see these sub features. Now when we use now when we use separated beam configuration, then actually these optically pumped atoms, they now get sufficient time to thermalize. So now there is no deficiency of zero velocity group of atoms, because before interacting with the probe beam, now they get sufficient time to thermalize, and hence we do not see any, so we see a smooth spectrum. So this is a story for the uncoated cell. Now the surprising feature is when even in the overlap configuration, so when you use this OTS coating in ARC cell, then also we see this smooth spectrum. So it means that elastic collision cross-section is far more than this inelastic collision cross-section. So
does it mean that in the cell, other than rubidium, there is some other gas?
Yeah. So this elastic collision cross-section, the enhancement of this cross-section is because the rubidium is colliding with this coating generated background gas, which is elastic, than this inelastic cross-section between the rubidium atoms.
Can we estimate how much of what is the fraction of that gas?
Yeah, that is a future that I said, that we have to estimate these collision cross-sections, that how much the elastic collision rate increased due to this presence of this gas. So that is the future. So that is the next step of this work.
Okay, thank you. Savareen Khate, anything you want?
What is the, I mean, typically, what do you think is this coating generated background gas?
Sorry?
You said coating generated background gas, right? What molecule you are expecting?
I cannot actually clearly hear. What is the coating generated background gas?
Yeah.
Well,
what is this gas?
for that, so that we have to see. I mean, that is, I'm not very sure what is this
Okay,
gas,
then
but
another question is, suppose
yeah.
you keep on, decreasing the temperature of your cell. Have you studied that effect? What happens?
No, actually, the study was done at constant temperature, but
Yes.
probably if I decrease the temperature, then the collision rates should decrease. And but yeah, so now I have to see whether the elastic collision or inelastic collision dominates at low temperature. Yeah, so yeah, that study I have.
Keep on lowering the temperature, then maybe the vapor pressure inside the cell will decrease, as
Right.
well as this effect of background
Right.
gas also should decrease.
Yeah, yeah.
Okay. Can we move ahead?
Yes, we can.
Okay. Next.
So, so I request the presenter, if possible, please switch on your cameras also. So our next presenter is Ayan Kumar Pal from BRC, and his poster number is CP0905. Mr. Ayan,
Yes, sir.
please
Good
continue.
afternoon. Good afternoon. I am Ayan Pal from NLS BRC sector. BRC OPEX is ICOS spectroscopy, high finness cavity spectroscopy. It is very important for high molecular transition direction and trace molecular direction. And this offers the immunity against the mechanical vibration and misalignment of the laser with respect to optical high finness cavity. But these spectroscopic techniques suffer from the low throughput of the cavity due to the low coupling of the laser to the optical cavity, which is more prevalent when the cavity mirror reflectivity increases. So to sort of this shortcoming can be overcome by repeatedly recycle the back reflected mirror from the formed mirror of the opaxis cavity using a re-injection method by application of placing an additional estimating mirror with a hole in front of the front mirror of the opaxis cavity. In this regard, I have done a theoretical simulation in theoretical simulation using the Python software. And the left bottom corner is the schematic of the simulation, and the right side the parameter used in the simulation process. Two mirrors are used in this regard. The diameter of this both mirror are 2 inch, and the radius of curvature both mirror of the reinjection mirror is Rx is equal to 100.1 centimeter and 99.9 centimeter. And the radius of curvature of the main cavity mirror is 100 centimeter, and there is a hole on the reinjection mirror at the position x0 is equal to y0 is equal to 1 centimeter. Next slide, please. And for this simulation, I have used the standard ABCD matrix of the level of optical cavity, and in this regard here we have changed two parameters: the length of the reinjection cavity and the angle of the incoming beam at the hole of the reinjection mirror to see the impact on the number of reinjection. So as a result, we have got the reinjection number depending upon the length of the reinjection mirror. In this regard, for the 50 centimeter cavity length mirror, we get the less reinjection, and for the cavity length d is equal to 70 centimeter, we got the maximum reinjection. And the right hand side of the picture is giving the optimized angle at the reinjection mirror. Next slide, please. And this is the spot pattern optimized at the optimized coordination. The upper left corner is the reinjection, the spot pattern on the reinjection mirror, and the right side upper is the spot pattern of the cavity front mirror, and the below is the reinjection mirror spot pattern for d is equal to 50 centimeter. For that we got only 6 reinjection. So in this regard, as a conclusion, I told that in this regard we have optimized the cavity length and the input angle to optimize the number of reinjection in the off-axis cavity enhanced spectroscopic method. So in this regard, the problem of the low throughput over, sir.
Hello.
Hello, sir.
See, this technique you have done a theoretical calculations. Do you plan to use them also somewhere, or it is just a calculations so far?
For the timing is just a calculation. In future, I want to incorporate in the experimental setup.
Uh-huh. How much is, what is the limiting factor in this case? I mean, if you want to detect something, what is the limiting factor you are going to?
In op-axis ICOS cavity, the main limiting factor is the throughput at the output signal, that is the very low, because in the high reflectivity mirror, the maximum laser light is reflected back from the front mirror of the optical cavity. So as we increase the optical path length via the increasing the reflectivity of the mirror, the output signal is added into the noise of the step. So to increase the detection sensitivity, we put a reinjection estimating mirror to reflected back the most of the laser light into the optical ICOS cavity.
Thank you. Nakhate?
Gain in reinjection or not, if you don't reinject or you reinject,
yes,
the
sir.
path length change. Expect. If you don't
if
if you don't use that mirror which is on the back side of the cell, then what is the
yes,
gain? What is the order of change in the path length?
There is no change in the path length, but it is the output intensity changes. We cannot realize the actual optical path length that we gain because of the low intensity at the output.
Number of passes will be same.
For first beam, the number of passes would be same, but for the second beam, it is
for the
much
re-injection I'm talking. If it is re-injected, then it traces the same path as the primary beam, or it traces a different path. Yeah.
It traces a different path.
Then the number of passes will be different, certainly.
Yes, but not much more.
How come it will? If it traces the different path, then if second time if it re-injects, the number of passes will be double.
No, the passes will not be double, but intensity, as it is, I calculate this as intensity wise, not path length wise. Actually, path length is.
If it is intensity is changing only, then it should trace the same path. I think so.
Okay, I think enough. Sabri, you want to ask?
Yeah. Okay.
Because we have to take time also is a factor, nahi?
Yes.
We can go to the next one, na?
Okay, so thank you, judges. So next presenter is Gautam Chakravarti from BRC, and the poster ID is CP0907. Mr. Gautam, can you see the slides?
It's missing.
07, na?
Mr. Gautam.
Hello.
Mr. Gautam, please continue.
Good afternoon, everybody. Today my talk is synthesis of body P analogs for their use as efficient dye lasers. This is the outcome of this is the outline of my talk: synthesis, solvatochromism and photo stability study, resultant discussion and conclusion. Next slide, please. This is the synthetic scheme where we prepared two different dyes incorporating two different substitutions depending upon their positions. We have characterized their property in different solvents. As we can see from the table that both the dyes shows a good solvatochromism property because of increasing the dipole moment at the excited state. So when we increase the polarity of the solvent, its absorption and emission wavelength shifted to the red region, indicating the increasing their interaction with the polar solvents. This gives a hint that we can tune the property of our laser dyes according to solvent or the micro environment of the dye surrounding. Next slide, please. This is the photophysical photo decomposition characteristic of the dye in comparison with conventional PM567 dyes, where we see that both the dyes shows a very good photo stability compared to the used pyromethane 567 dye. The dye which we prepared earlier by substitution at the position 2, it shows enormous photo stability in the presence of 4 watt of Nd:YAG laser irradiation at 532 nanometer wavelength, whereas Day-2 relatively less stable, but it is stable, comparatively more stable than the pyromethan 567. The Day-2 shows emission at around 570 nanometer. So this gives the property of the dye that where we can use or we can utilize our the synthetic dyes for our strategic isotope separation process, where it has not been explored so far. And both the dyes from the synthesis and the photophysical and the photo stability study, it shows that the dye has the potential to be used for the future scope of application, where we can tune the property of the dyes according to the change of substitution at the various position of the body P core. Thank you very much.
Okay, Gautam, you have studied these two dye. I mean, first thing, can you tell me that just by changing the solvent, you can get the tuning range different? You can.
Sir, actually, we cannot change a huge change, but here we can see there is almost a 10 to 12 nanometer shift is there if we change the solvent polarity from low polar solvent to high polar solvent. So, but this gives the indication if we increase the polarity of the body P core by incorporating some other substituents, then we can tune also the property of that even more than this 10 to 12 nanometer. We can even further go to even 50 nanometer can be tuning can be possible for different dyes which have been reported earlier. Not in the body P dyes, but for different dyes.
And the second thing is that actually the testing of this dye, finally, you said it will be for some strategic application. It will be used at a very high, those power, I mean, unless they are tested at those powers, the decomposition and all this thing, because normally at the low power, most of the dyes are stable. When you go to high power,
sir, actually we tested at a high intensity Nd:YAG laser irradiation 4 watt up to 4 watt and pulse repetition rate of 10 hertz in that at a very intense laser irradiation. So it is giving the very good stability, sir, compared to the conventional using the pyromethan 567 dye. So it has the indication that we can tune the property, not only the property, even also photophysical stability also with the dye with the for our various purposes like our strategic isotope and some other purpose also that biological.
Okay. Thank you. Sabri,
What are the typical solvents that you are using for this?
Madam, here we have used ethanol, methanol, 2-DCM and non-polar hexane. So we can tune the property according to their dipole moment or polarity index of the solvent from ethanol to non-polar hexane.
So, can you comment on the thermo-optic properties of these dyes, dye lasers, when you are using these organic solvents?
Actually, madam, in case of volatile organic solvent and for this benzene, hexane and all, thermo-optical property will be very poor. But in case of more polar solvent or high boiling solvent like ethanol or water or some other cases, thermo-optical property of the dyes are very stable and very good. We have also tested it, but not here we can show, but it shows a very good property due to very small change in refractive index gradient in that high specific heat type of solvents like water, ethanol and all.
Shall we?
What is the quantum efficiency of this dye is compared to the conventional one?
For 567, it is around 90%, and in our cases, that second dye, which is at position 3, it is around it is 75% quantum yield is there. But dye 2 is comparatively less. It is 10%.
How does it compare with the conventional, the pyromethane and things like? Is better or inferior?
It is relatively small. That dye 3 is a little bit less. But if we compare the stability, it overcomes that little margin of this difference in the, quantum yield or quantum efficiency.
How costly are these dyes compared to the standard dyes?
Madam, these are actually synthetic dyes, so cost comparative analysis we have not done yet, but these are these dyes can be synthesized quite easily and frequently. Only the process of separation is little tedious. That manual labor is tedious, but reactants are very cheap.
Okay.
Okay.
So we'll move to the next presenter.
Right.
Thank you,
Ms.
sir.
Aradhana Tripathi from University of Allahabad, and the poster number is CP0908.
Am I audible?
Yes, you please continue.
Good afternoon, everyone. The title of my presentation is Potential of Confocal Micro-Raman Spectroscopy for the Determination of the Impact of Treatment of Silicon Dioxide Nanoparticles on Maize Seedling. The identification of the biochemical and effect of the treatment of the nanoparticles on plant growth is a challenging task in present scenario, as most of the traditional practical techniques like mass spectrometry, liquid chromatography, etc., are limited by need of extraction of biochemicals into the solvents that requires large amount of the sample and are time consuming, labor intensive, and cost effective. In view of these limitations, the confocal Raman microspectroscopy technique is rapid, non-invasive, label-free, extraction-free vibrational spectroscopy techniques, and based on a phenomena of inelastic scattering of light due to the vibrational bonds of the molecules. Next slide, please. Coming to my experimental details, the male seedlings are grown in the laboratory under the controlled conditions and supplemented by Hogland nutrient solution. And after 6 days of the initial growth, the seedlings are treated with the silicon dioxide nanoparticles at concentration 0.2, 0.6, 1.0, 1.4, and 1.8 millimole, and the untreated seedlings are regarded as control. After 4 treatment, the Raman measurements were performed. The Raman signals were excited by focusing 785 nanometer diode laser on the addoxial surface of the secondary leaf of the bed sizzling with the help of BX43 microscope and 10x objectives. The scattered signals were recorded with the help of Android Solid software using a charge coupled device as detector. Next slide. So coming to my results and conclusion, this is the combined Raman spectra of the control and silicon dioxide treated maize seedling. The strong peak at band number 15-18 centimeter inverse and band at 990, 1182 centimeter inverse, the presence of at night, while the band at 511, 746 and 912 centimeter inverse correspond to the cellulose. From the table, it is very much clear that on increasing concentration of the silicon dioxide nanoparticles, there is an enhancement of the amount of the difference biochemical present on the leaf of maize seedlings. The analysis of a scattered plot reveals that the score of the principal component first are able to capture 92.88%, while principal component second is able to capture 3.26% of the total variation in the data sets. The loading plot of the principal component first and second shows the positive loading at 509, 743, 910, 991, 1051, 1148, 1180, 1220, 14, 30, and 15, 17 centimeter inverse, while principal components first shows only negative loading at 717 centimeters, and principal component second shows negative loading at 402, 717, and 1067 centimeter inverse. Thank you.
Radhana, could you please tell me what is the motivation in doing this type of study?
Yes, sir. Actually, I think the effort should be made to monitor industrial and commercial applications to prevent environmental contamination by nanoparticles. I have also performed this experiment using different nanoparticles, but here I have shown silicon dioxide nanoparticles, and this is from my result. I can conclude that silicon dioxide nanoparticles enhances the mechanism of the formation of these chemicals, so it is beneficial for plants. So I think it is not toxic for our environment and plants.
Okay. दिखाते.
So our next presenter is Sunita Alvat from RRCAT, and the poster number is CP0909. Miss Sunita, can you hear?
Yes, yes.
Please
Yeah.
start.
So can I start? Okay. So good afternoon. So topic of my presentation is demonstration of a standoff laser-induced breakdown spectroscopy setup. So this laser-induced breakdown spectroscopy has many capabilities because it allows simultaneously multi-element analysis of solid, liquid, gaseous samples in ambient environment without requiring vacuum conditions. It doesn't require any sample preparation, and it allows analysis of light elements where X-ray based techniques do not work properly, and also samples can be analyzed in proximity to the detector as well as far away from the detector. And this far away from the detector ellipse technique is normally called standoff ellipse. This standoff ellipse has applications in industrial process monitoring, archaeology, planetary exploration, and hazardous material identification, etc. And we have developed in RRCAT a standoff ellipse setup using a 1064 nanometer laser and spectrometer equipped with CCD and a 4-inch Cassegrain telescope, which is capable of analyzing samples from a distance of 6 meters. So next slide, please. This is our experimental setup. We have used a 1064 nanometer laser, and 180 millijoule was our energy on the sample surface, and it was 6 nanosecond laser with 10 hertz repetition rate. Laser was expanded before focusing it to a distance of around 3 meters, and a signal generated by the plasma emission was collected in the direction collinear to the laser incident direction, and it was collected by a 4-inch telescope. And the detection and the signal collected by telescope was coupled into a spectrometer, which consisted of 4 spectrometers, which were electronically synchronized and which covered a range from 300 to 815 nanometer with a spectral resolution in a range from 0.13 to 0.18 nanometer and a fixed integration time of 1 millisecond. We tested our this setup on stainless steel samples, 2 different grades, SS304 as well as 316, and also on 3 different rock samples collected from the hilly regions area near Indore. And okay, next slide, please. This we show stainless steel sample analysis on the when we performed 50 spectral averages on SS304 and 316. We could distinguish between these 2 grades on the basis of appearance or absence of molybdenum peak, because SS316 consists of 2 to 3% molybdenum and SS304 doesn't contain. So this peak appears at around 553.28, and it was on this complete spectrum 300 to this full range. But if we couple all the signal into a only single spectrometer, we could increase signal to noise ratio, and we could even distinguish between the 2 SS grades on the basis of single spectrum. So it would allow us real-time analysis. Similarly, we performed rock sample analysis, and we could distinguish the 3 rock samples on the basis of the elemental composition. Say rock 2 and 3 consisted of higher concentrations of Na and Fe. So we plan to further increase the distance as well as other sample matrices we want to include in our future studies. Thank you.
Over to judges.
Hello.
Yes.
How do you decide the energy of your laser, pulse energy of the lasers?
Using a meter? Use a commercial energy meter?
No, whatever energy you are using, suppose you increase that energy, with your detection limit will increase or reduce, what will happen?
We need to check that, but I think we are at if our energy is very low, say less than 50 millijoule or something, we are not able to detect the spectrum. But if we further increase the energy, we need to see, because that plasma shielding effect also start taking place at higher energy level. So we need to see this what happens if we further increase the energy and like that.
But for your this setup, testing the setup, you must have done some energy analysis, na? That some variation sort of thing, na? Dependence of energy, ni? Anyway.
First, actually, without varying energy, I was testing the distance, because I just started keep on increasing the distance, and once I reached the distance which my lab allowed, I stopped there. So these were the results.
Okay.
We need to do that also.
Okay. Sabri, Khate, please. So, you people can ask whenever you feel like, honey. You don't have to wait for my this thing signal. Okay.
So in your rock sample analysis, Finally, how you are able to distinguish these different types of?
1 3.
Yes, ma'am. We collected some, say, 50 spectra from individual rocks, and then we perform principal component analysis because we expect that all of these main constituents are similar in different rocks, but relative concentration is expected to be different. So we perform principal component analysis. That is a multivariate analysis technique, and on the basis of the loading plot, the positive and negative values of loading plot, we
So you have to have a library for that of the overall geography.
Yes, we are working on that. We are building library on the basis of this, whatever samples we perform analysis on, and the peaks which we can identify.
Okay.
This does it the plasma emission basically is a function of wavelength as well. So probably the India, the 1064 will be better, or the UV laser will be better for this. The third
1064 or any 1064 and
355, suppose. Does it have any effect on the plasma emission?
yes, sir. It can have. Say, if I use shorter wavelength region, in that case, the starting of plasma means the multi-photon ionization effects. All those things may come into picture. And for some samples where absorption, because absorption also varies with the wavelength. So in that cases also the dependence of wavelength come into picture. So like that.
You have not made any studies so far on that.
Yes, sir. We have this wavelength only. So we are working on 1064 only.
So shall we move to next?
Yeah.
Yes.
So next poster presenter is Sarabjit Kaur from IIT Ropar, and the poster number is CP0913.
Sir, am I audible?
Yes, yes. Please continue.
Okay. Okay, sir. Okay. So, good afternoon, everyone. I'm Sarabjit Kaur from IIT Ropar. My work is on an investigation of the surface activity for aqueous binary miscible polymer blends by nonlinear laser vibration spectroscopy. Next slide. Hello, next slide. Okay. So basically, synthetic polymers used in polyelectric has revolutionized device application by providing ionic conductivity and flame retardant properties. And this way, the polymer blends has also introduced and improvised the polyelectrolyte properties. And it is utmost required that how fundamental understanding of their role has improved the ion conduction properties. So based on that, we have selected two polymers. One is polyethylene oxide, and other is polyphosphosine based derivative made. And we are interested in studying that how the blend of these two studies makes an improvisation as a modifier. So target of our study is what kind of surface modification at molecular level does polymer blend have at the interface. So in order to do that, we required a molecular spectroscopy technique, which should be quite surface sensitive. Next slide. So based on that, we have used some frequency generation vibration spectroscopy, which is quite surface sensitive technique. And this is basically a nonlinear optical based phenomena. And the shown diagram is the used optical layout we have used for our experiments. And the SFG is basically a phenomena which is formed from the formation from the input of two laser beams. One is fixed visible and other is tunable IR, which get spatially and temporally coherent. Please, last slide. Hello. Okay, so basically this is a parametric process which required energy and momentum conservation at a time, and the SFG signal get resonantly enhanced when the molecular response of have a resonance with the input incident beam. So this way the response provides the vibration response of all the molecules which are present at the air liquid interface. Next slide. So based on this technique, we have characterized our study on two sets. One is having different variations of polyethylene oxide (PEO), and from our study from figure A and B, as you can see, that we found that the backbone structure of the polyethylene is highly present at the interface and does affect the hydrogen bonding environment of the water molecule, which can be seen from the and this is because of the involved polymer hydration. And similarly, we found that when the addition of polyethylene oxide and does does take place at the interface, the PEO highly affects the surface ordering of the MAP polymers. So as a result, we found that this inclusion of the polyethylene oxide highly affects the hydrophobic transition. So and surface tension study also provides the same idea about the MAP adsorption. And the morphology study of SAM and XRD provides that there does take place some transitions from crystallinity to amorphous characters. So with this way, I conclude my results. We found that the PEO presence in the MAP is highly affecting the surface ordering of the air-liquid interface, and also this intrusion of hydrophobicity highly play a role in the change of morphology from crystallinity to the amorphous characters. Thank you.
Sarabjit, one thing, Sarabjit, you have used our time also actually. Anyway, you tell me this work is going on in IIT Ropar for many years. What way it is different than what was presented 2-3 years back?
Okay. So basically, every time we try to characterize the different environment of aqueous or where we can see air liquid probing environment of molecules. So this time we were targeting the blends of polymers, that how the fundamental understanding of this could helpful in understanding the electrolyte and electrode interface through aqueous environment.
Okay. I think we can go ahead.
Yeah.
Next one.
Yes.
Next.
Okay, sir.
Thank you. Thank you.
So
Okay,
next next presenter is M. Kumar from Sri Venkateswara University, Tirupati, and the poster number is CP0916. Mr. Kumar, can you hear us?
Yes, sir. Good afternoon, sir. I am
Please continue.
Good afternoon, sir. My work is on impact of different modifier fluorides on optical properties of trivalent samarium doped bismuth phosphate nanocrystals in bismuth phosphate glass and glass ceramics. So in order to choose better host for different optical properties, we have reported that structural and spectroscopic properties of samarium 3+ doped glass ceramics with varying modifier fluorides by keeping the samarium concentration constant. So next slide, sir. Experimental techniques. We have adapted the melt quenching technique for preparation of my glass samples, glass ceramic samples. Here, the molar compositions are phosphorus pentoxide 59.5 mole percent and 15 bismuth oxide and 10 mole percent of barium fluoride and 10 mole percent of different modifier fluorides such as lithium fluoride, sodium fluoride, magnesium fluoride, potassium fluoride, calcium fluoride, and strontium fluorides, and 5 mole percent of tellurium oxide by keeping the 0.5 mole percent of samarium oxide concentration constant. And the densities and the refractive indexes of these glass ceramics has been measured by using the Archimedes principle and Abbe's refractometer. In Abbe's refractometer, we have used sodium lamp as the source, and glass ceramic materials were distinguished utilizing expert paralytic XRD copper K alpha as a source, and UV visible spectrometer for optical studies. Fluorescence studies has been studied by using the 150 watt xenon lamp as excitation source, and figure 1 source in the results and discussion. Figure 1 shows the XRD profiles of the prepared glass samples, sir, in which by using the expert high score software, we have confirmed that the phase is bismuth phosphate phase. All the glass ceramics has been given uniform phase, and this phase has been determined by using FTIR. In the next slide, I have shown that, and the crystal size has been determined by using the Sterner relation, and the average size of the crystal is 51 nanometer. That is, please, sir, go to the next slide. So this is the FTR spectra of the synthesized glass ceramics, in which I have recorded from 400 to 4000 centimeter inverse energy range. We can observe from the figure that various functional groups present in the glass ceramics, that is from 400 to 600 nanometer. There exist IR features of bismuth oxide, BiOC, and Sir, can I continue, sir? Optical properties, that is photoluminescence spectra. Figure 3 shows the photoluminescence spectra, that is excited at 401 nanometer. We have got 4 bands from 4G 5 by 2 to 6H 5 by 2, 7 by 2, and 9 by 2, 11 by 2 bands. From this, the higher emission cross section for potassium incorporated glass. So that is why consequently we have got optical gain and optical gain bandwidth higher for potassium glass ceramics, so, which is suitable for developing the lightning applications and optical amplifiers. This is suitable medium, sir. Potassium incorporated glass ceramic. That is also.
Okay.
Mekhate, Sabri, you want to ask any question? Otherwise, I am okay.
Okay, sir, we can move ahead.
We can move on, na? Right.
Okay.
Thank
So
you. Thank you.
So next presenter is Parmeshwar Reddy, and the poster number is CP0917.
Hello. Good afternoon, sir. I am Parmeshwar Reddy from Highwood Engineering Lab, IIT Madras. My topic is adoption of LIPS technique for quality control of nanoparticles produced by automated wire explosion process. Next slide, please. From previous studies, LIPS have shown good correlation between surface hardness of the material and with the electron temperature. So this study mainly aimed on the assessment of surface hardness of the material through the electron temperature measured from the LIPS technique. We generated aluminum nanoparticles with wire explosion process with the different pulses of 10, 20, 50, and 100 in the various ambiences like nitrogen, helium, and argon. And we prepared a pellet using these nanoparticles in a circular disc manner with 20 diameter, and the results of the resultant samples were subjected to LIPS and studied at various energies of this laser. Next slide, please. Figure 1 shows the schematic diagram of the LIPS, where laser is generated from the source and impinged on the sample through the laser lens 1, and the plasma generated at the sample is captured by the lens 2, and it is that plasma is measured using optical spectrometer, and these plasma intensities were recorded. And figure 2 shows the LIPS spectrum of the figure 2 shows the LIPS spectrum of the samples produced at different pulses, and we can see all the pulses have same pattern. uh, and when we see the figure number 2b, here we measured the plasma spectrum with the variation of plasma energies, and it was found that uh, beyond the 60 millijoules, the plasma intensity peaks were saturated, and we concluded that 60 millijoules is sufficient for getting highest peaks. And figure 3 shows the plasma temperature, which is measured electron temperature, which is measured from the spectrum at the different ambiances with different pulse modes, and it is concluded that plasma temperature remains relatively constant with the number of explosions, and sample nanoparticles which are produced to prepare a pellet has shown higher plasma temperature, which is similar to that of metal block. Thank you. Yes, sir.
Over to judges, please.
Nikhate, you can ask.
What is the conclusion of the studies? I miss the aluminum metal target and
Here we generated aluminum nanoparticles using wire explosion process, sir, under different ambiances, and we concluded that helium ambience is producing lower nanometer sized nanoparticles, which is indirectly.
What is the role of the ellipse in this, in characterizing this?
Assess the surface hardness of this nanoparticles pellet product.
How can you measure the surface hardness by ellipse technique?
Actually, we correlated with we used plasma temperature to correlate between surface hardness and the plasma temperature.
Yes, India too.
Okay.
So, shall we continue to next?
I think we can go to the next one, now.
Okay, so our next presenter is Mr. Vinod from IIT Madras, and his poster number is CP0919.
Good morning, everyone. I am Pabati Vinod, a research scholar from IIT Madras, India. Today, I would like to talk on a paper, Investigation on Pollution Performance of Silicon Rubber Micro Nanocomposites by Adapting LIPS Technique. Introduction. Silicon rubber insulators are giving more importance in power system.
Mr. Vinod, your voice is not very clear. Please speak a little louder.
Okay. Silicon rubber insulators are, now is it okay?
Right. Go ahead.
Silicon rubber insulators are gaining more importance in power system as electrical insulation in transmission and distribution network with their superior properties like lightweight, higher Vandal resistance, hydrophobicity, and hydrophobicity recovery characteristics in polluted environmental conditions over traditional insulators made up of porcelain, ceramic, and glass insulators. However, the addition of small weight percent of nanofiller or microfillers can significantly improve the insulator properties. And interestingly, the contamination accumulate on the silicon rubber insulator can alters the surface flashover voltages. So it is necessary to understand the type, the level of the pollution on the outdoor application of silicon rubber insulators and different type of the pollutants. So here LIPS, laser induced breakdown spectroscopy, is a non-destructive technique which is allowing the materials to characterize the performance of the materials based on their contamination on the silicon on the surface of the material. And to this LIPS approaches, the machine learning techniques are assisted, so such that there will be a classification using the material composition. Next slide. In figure 1, we can see with respect to different ESDD values, means different the same contamination with a different contamination level increases, that is represented by ESDD values E1, E2, E3, E4. And here we can see in the figure 1A, there is a increment of sodium and calcium, and the same thing is measured in temporal characteristic, that is shown in figure 1B. So further classification, we have used the ANN technique with the different algorithms. There we have classified successfully the contamination level on the silicon rubber insulator, and here green color boxes shows the successfully classified data, and red color one shows the error value. Interestingly, we have classified 100 with the 100% accuracy the contamination level on the silicon rubber insulators. And here different algorithms we have showed, where CCP training algorithm shows the 100% accuracy as well as the very less number of approaches. Thank you.
What happened?
Thank you.
Finished?
It's okay. Thank you.
So you mean that
these algorithms developed by you?
Sorry, ma'am. Come again.
These algorithms are developed by you, or these are available, occasionally available?
Ma'am, your voice is not audible clearly.
These algorithms which you mentioned, are they available commercially, or you have developed them?
Yes, commercial available. We are not developed.
Okay.
Yeah.
And this silicon, I mean, after finding out the contamination in the silicon rubber, I mean, what is the exact goal of this? Why
Yes.
to find the contamination?
Yes, yes. Contamination on the insulator surface will increase the flashover. Sorry, reduce the flashover voltages on the material, because when contamination is there, there is a formation of water droplet which will spread on the insulator. There, so this flashover voltage will significantly reduce. So lifetime of the insulator will decreases. There will be tracking or carbonization on the material.
Okay.
With your method, can you predict that now at this deposition the flashover is going to happen? Can you predict that? Is it predictable, or it is just studies like that?
Sir, it we cannot, means we can classify the contamination level, sir, means based on the ESDD values, what is the contamination level. So with the help of that one, we can predict definitely if there is a ESDD, means contamination level is high, so there is more possibilities for the flashover voltages.
Okay, I think so.
So you mean to say, like, when to change the material that you can in advance you can predict?
Yes, ma'am. In service, we can use when the insulator in the service, we need not to take it out and test in from the old methods. Now this is the new technique where the insulator is in live. We can get the composition like Lips spectra. From that, we can categorize, predict.
Okay, we are through.
Thank you.
Thank you, sir.
Next.
Okay, so our next candidate is Deepti Mai Biswal from BARC, and the poster number is CP0920. So can you hear Deepti? Deepti, are you there? Deepti, you are you have to unmute yourself.
Hello, am I audible?
Hi, yes, you please continue.
Okay. Good afternoon, everyone. My topic of presentation is three-step three-color selective photoionization of natural ytterbium for enrichment of YB168. YB168 is a precursor isotope for the generation of radioisotope YB169, which generates low energy gamma particles with energy 52 keV, ranging from 52 keV to 310 keV via electron combination. These low energy gamma particles are very suitable for nuclear medicines and as well as industrial sectors. So YB169 can be produced from YB168 through N-gamma reaction with cross sections of 2300 bar. And that the nuclear abundance of YB168 in natural YB is 0.13%. So to produce a high purity YB169, we have to enrich YB168 to more than 15%, greater than 15% from its natural abundance. Here I will discuss the laser-based isotope separation method to enrich YB168. Next slide, please. So laser-based isotope separation method comprised of three main elements. The first element is atomic vapor source to generate a collimated atomic beam. Second component is high power, high repetition rate lasers to selectively ionize the targeted isotopes in the interaction zone. And the third component is suitable collection systems to extract the photoionized isotopes from the interaction zone. So we have used the three-step three-color schemes that is tuning lasers at 555 nanometer and 581 nanometer and 582 nanometer. YB can be that particular isotope can be selectively excited and subsequently ionized to the autoionization via autoionization state at 5 to 353 centimeter inverse. This experimental setup consists of copper vapor laser MOPA systems and diode pump lasers, diode pumps solid state laser, which pumped three high power, high repetition rate dye laser. And these three dye lasers are spatially overlapped and time synchronized to form a combined beam. And the part of the beam is sent to a time of flight based resonance ionization mass spectroscopy setup. Where the we develop the protocol for selectively ionize the YB168. Next slide, please. So here the spectral profile of YB168 in the vicinity of other YB isotopes is given. For the first step, the YB168, the interfering isotopes of are YB171 and YB173, which are very close to YB168, approximately 168 megahertz and 150 megahertz. And in the second step, that 171 and 173 hyperfine components are is greater than.
Please try to complete fast.
Okay, and with this spectral means profile data, we successfully demonstrate on three-step selective photoionization of YB168 from natural sample, and we qualify the process parameters, that is the laser transition wavelength and laser intensity. And in actual enrichment experiment, we have achieved 10%.
Hello.
Yes, sir.
Dipti, just I wanted to ask, in your mass spectra,
yes, sir,
you had shown one peak, when your all the laser wavelengths were tuned to 168, isn't it?
yes, sir.
I mean, the other isotopes were not visible in the spectrum, isn't it?
Yes, sir. Yes, sir.
No, you say in the actual run you have only 15%.
Yes, sir.
Why it is so?
Sir, actually, in actual run, the residual Doppler width is 300 megahertz, whereas in time of flight mass spectra it is 100 megahertz. And in actuals, that is the first parameters. What happens that the other isotopes, the wings of other isotopes are the center of the laser tuning means wavelength that will excite and will subsequently ionize and appear in the interaction zone, and that also will get the will be extracted and collected by the collector plate. And the second point is what the non-selective collection means that what happens, it is that only 0.13% abundance is means YB168 abundance is 0.13%. So the other isotopes is more abundant, and that can be collected at the collector plate, so that will degrade the isotopic enrichment.
Other than ion collection, is there any other process which can spoil your selectivity in the process?
Other than, sir?
Ions, you said because of the Doppler broadening, you are in the chamber, the other isotopes are also getting ionized.
Yes, and other is non-selective collection, sir. Non-selective collections, because the vapors are expanding, and that vapors means that atomic beam can be can get deposited at the collector plate.
Okay. Now in your this total process, you have a 4 component. One is spectroscopy, vapor generation, collections, and lasers. Which was the more challenging in? I'm asking you a question. Which part is the more challenging for this process?
Sir, actually, I think actually For YV, the most challenging is the efficient collection system.
Okay,
And,
okay, we will discuss. Okay, Sabri and Nakhate, you can ask now. Nakhate, Sabri, anything you want to ask?
The separation rate is 0.04 milligram probably, right?
yes, sir. Yes, sir.
How do you estimate then how much run you have did for this to come at this value? And is there any specific some portion of the
Sir, you are not audible clearly. But what I understood, you want to ask me how that 0.04 milligram per hour it is achieved, or it is means how the estimation is 0.04 milligram per hour.
Yeah.
Okay, after collection, it was means in the sample is collected in nitric acid medium, and that in that medium it was.
It is a run of some few hours or something like that.
Yes, sir. Yes, sir. We have to we have to run for 2 to 3 hours or 4 hours. Then we.
Okay, 2 to 3 hours. Okay, okay. And any specificity on the collector portion or something like that, follow over whole the collector you have estimated that, or any specific portion of the collector?
Sir, we have actually zone-wise collections has been done, but
This is the best one, and this is the best one. I think.
best one. Yes, sir.
Okay.
Thank you.
We can go ahead.
Next time.
Okay, so our next presenter is Biswajit Jana ji from BRC, and his poster number is CP0922. Mr. Jana, please continue.
Yes. Good afternoon, everybody. I will be talking about the estimation of isotopic composition of targeted lutetium-176 in the three-step isotopes. This is not much. This is okay, in the three-step photonation method. So basically, lutetium-177 is a promising radiopharmaceutical isotope in cancer therapy. It is produced by either 176 YB, otherwise 176 lutetium. From their natural abundance 12.9% and 2.6% respectively in the reactor by neutron absorption method. Since if you see the cross section of this method, it's for ytterbium case 2090 bond and lutetium case only 2.4 bond. So you can see that, there is a factor of 1000. So only few milligram lutetium 176 is required, whereas few grams YB is required. So this lutetium enrichment can be achieved through Ablis process, which consists of evaporation of lutetium 170 lutetium evaporation, collimation of vapor, and selective ionization of 176 isotope, and extracts of ions and minimization of the non-selective pickup. So I use the three-step photoionization method to selectively excite and ionize the targeted 176 isotope. Red equation based model, including all hyperfine structure of the lutetium, has been developed to process to study the kinetics. My aim is to just calculate the isotopic composition of laser atom interaction volume as the product collector plate. Actually, my presentation, excuse me.
Yes, Jana, bolo. Hello. Hello.
Mr. Jana, please continue.
What happened to Jana?
Mr. Jana, you are muted. Please unmute yourself.
Yes. So here, this is the hyperfine structure of the first step transition. You can see this circle one. This is the targeted one. So it is 2.4 4 gigahertz apart from the nearby hyperfine component. Similarly, in the second step hyperfine structure, if you see, they are widely separated and the selected transition is nearly 7 gigahertz from the nearby component. Okay, next. Here basically I have calculated, including all the hyperfine possible transition, I have calculated. It is calculated that nearly 98.6% isotopic composition is been achieved in the laser isotope separation. If you calculate the product enrichment at the product collector plate, we need to consider the non-selective pickup. Here I have calculated including this non-selective pickup with the ion photoionization yield. It is estimated that the enriched product of 75% more than 4 milligram, 0.4 milligram per hour is achievable Lablis process. And for this, we need to more than 30% ionization yield is required, and non-selective pickup should be less than 0.05%. Thank you very much. Excuse me, sir.
Hyperfine structure data for this second step and second step specifically, and the cross sections are known, or you have estimated from?
Actually, the hyperfine, the component, the hyperfine, the constant A and B, they are whatever we are using the scheme, they are known, and from the transition probability, I have calculated the cross section in the tabular form.
You are pumping all the hyperfine levels to get this selectivity and the yield.
Yes, yes,
all the hyperfine or one of the hyperfine structures.
Yes, I have shown that all the possible transitions, nearly 26 transitions are there for 176 as well as 175. From that, I have calculated the selectivity.
Can you achieve this practically?
Can you achieve the? Yes, yes. In the time of
so many lasers will be required, right?
No. Actually, all the possible transitions. Only I have targeted the one possible hyperfine.
One of the hyperfine.
Yes, one of the hyperfine transition. It's I have targeted.
How much population you will be utilizing atom utilization in this when you are targeting only one hyperfine component?
Yeah, sir. Actually, if you see the source temperature of 1800 degrees centigrade, we are getting at the ground state only 70% atoms.
No, that particular. No, you are using
only one hyperfine component.
This partition function.
You are using only one hyperfine component, right? So how much population is accessible to you?
Yeah.
Yes, I am saying that on 8.5, this hyperfine level, this is only 30% of the ground state level is available.
How many components are there actually?
In ground state, sir, 4 components are there.
So why there should be 30% in that one?
Yeah, actually, they are distributed over the 4 levels.
4 levels, yes.
They're having 8.5, 7.5, 6.5, and 5.5. So at the highest level, 8.5, we are getting only 30% of the whatever the ground state, and in ground state, only 70% of the atoms.
Okay. Thank you, Jana ji. Thank you.
Thank you.
So our next presenter is Aishwarya Avasthi from University of Allahabad, and poster number is CP0924. Ms. Aishwarya, can you hear?
Yes, sir. Am I audible?
Hello. You are not audible. Little louder.
Hello. Hello.
Hello. Sound is not audible.
Hello. Yes, sir. Am I audible?
A little louder. It's very slow.
Not able to.
Am I audible, sir? Hello. Hello.
Hello.
Am I audible, sir?
Please speak.
Hello? Okay, sir. Okay. Good evening, everyone. My name is Aishwarya Avasthi, and the title of my presentation is the non-destructive monitoring of the biochemical response of mung seedlings treated with copper oxide nanoparticles using laser-induced fluorescence spectroscopy. For this study, we have taken the fluorescence spectra of the control and the copper oxide nanoparticles treated leaves by using the laser-induced fluorescence spectroscopy in the spectral region 600 to 900 nanometers. Next slide. The fascinating next slide, please.
Will you please speak little louder?
Hello. Hello.
Speak little.
Continue.
Sir, next slide, please. Yeah. So the fascinating properties of nanoparticles have found an extensive application in the field of pharma, diagnosis, chemistry, and so on. Copper oxide, one among such metal oxide nanoparticles, have found great application in the industry such as medicines, electronics, and so on. Under such scenarios, the fate of such nanoparticles remains limited in context to their interactions with the biological world. Therefore, we aim to investigate the changes in photosynthetic pigments of mung plants treated with copper oxide nanoparticles of different concentrations using laser-induced fluorescence spectroscopy, which is rapid, non-destructive, eco-friendly, and has multi-compound detection capability. The following is the laser-induced fluorescence spectroscopy setup, and it comprises of a 405 nanometer 50 milliwatt violet diode laser for exciting the sample. Then we have an fiber optic spectrometer equipped with optical fiber for registering the signal and a signal processing unit to record the spectra. The following shows the fluorescence spectra of the control and the copper oxide nanoparticles treated leaves of mung plants, and it is clearly visible that these peaks at 685 nanometer and 732 nanometers go on increasing as the concentration of the nanoparticles increases from 0.2 nanometer to millimoles to 1.8 millimole concentration. Now, the important factor that we always see is the intensity ratio between 685 nanometer and 732 nanometer. And we observe from this table that this ratio goes on increasing as we move from lower concentration of copper oxide nanoparticles to higher concentration of nanoparticles. This shows that the photosynthesis quantum conversion is affected and the content of the chlorophyll in the leaves decreases. Last slide, please. At last, I would like to conclude that LIF can be readily used to monitor the interaction of nanoparticles with plants. The various parameters encompassed by this technique helps determining many physiological related to plants in context to photosynthetic pigments and activity. And moreover, LIF can also be used for remote monitoring of the vegetation under stress by determination in changes of LIF and intensity ratio. Thank you.
Over?
Yes, sir. Yes, sir.
Okay, why you have chosen copper nanoparticles?
Yeah, basically in the literature survey, when I did the literature survey, I found that copper oxide nanoparticles, actually in the literature, it was given that it has toxic effects on the vegetation. So I wanted to know that at what concentration or up to what concentration that was toxic or not. Because in some papers and some literature I did, then I found that the concentration ranging from 0.01 millimolar up to 2 decimal places, it was good for plants. But the higher concentration was hazardous to plants or it was toxic. So that was the main purpose. And
so for vegetation, where is the source of getting copper oxide, like, so that it becomes toxic environment for them? Is it more in Indian soil?
That I don't know, ma'am.
But it will be in the normal copper content or oxide. Why nanoparticles will play there? Why nanoparticles are required?
Sorry, sir.
Nanoparticles will be there in the environment of copper?
Yes, sir. Yes, sir. Yeah. Yes, sir. Because of the nanotechnology-based consumer products that are readily available. So we don't know what's the fate of those nanoparticles. Their demand and their use is ever increasing in our daily life. So what's the impact in agricultural scenario that we wish to know?
We can go ahead, me.
Yeah.
Yeah.
Okay.
Thank you. Thank you, ma'am.
Okay, so next presenter is Miss Seema from BIRC, and the poster number is CP0925. Miss Seema,
Audible
a little louder.
now.
Yes, yes.
Good
Please
afternoon,
continue.
everyone. The title of my presentation is Three-Color Isotope Selective Photoionization of Yttrium for YB174 Enrichment.
A little louder, madam.
The title of my presentation is Three-Color Isotope Selective Photoionization of Yttrium for YB174 Enrichment. We have carried out resonance ionization spectroscopy in an in-house developed time-of-flight mass spectrometer to precisely determine the wavelengths and intensities for three-color isotope selective photoionization of YB174 to a selectivity greater than 99%. Natural yttrium has got 7 isotopes with natural abundance as listed here, and among these YB174 is a precursor to the radioisotope YB175, and it's a promising candidate in cancer treatment. YB174 can be converted into 175 by N-gamma reaction in a nuclear reactor. In order to produce high purity radioisotopes, the precursor isotope need to be in enriched form. To this end, we have carried out three-color resonance photoionization of YB174, and this is the spectroscopic scheme that we have used in our experiments. Next slide, please. This is the schematic of the experimental setup. DL1, DL2, DL3 are the 3 tunable lasers that we have used in this experiment, and DL1 and DL2 are single mode lasers, while DL3 is multi-mode. All the laser beams wavelengths were monitored in a high resolution wavelength meter, and all laser beams are spatially overlapped and temporarily synchronized for ensuring.
Madam, little louder, please.
All lasers are spatially overlapped and temporally synchronized to ensure sequential absorption of photons. A part of the combined beam is sent to the time-of-flight mass spectrometer for laser qualification experiments before the actual collection experiment, and the main beam goes into the collection chamber. Now, this atomic beam is generated in the time-of-flight mass spectrometer, and it interacts with the laser beam in a perpendicular configuration. After this, photo-ions are collected by the detector placed at the end of the tube. And to start with, we have we use high intensities in the dye laser beam so that we can see all the major isotopes of YB174. Now the dye laser wavelengths are precisely tuned by utilizing the isotope shift data available in literature to maximize the photoionization signal for the target isotope. After that, the intensities are optimized to get maximum selectivity for the maximum isotope selectivity, and we have observed an isotopic selectivity of 99% for YB174. Next slide, please. So in conclusion, we have obtained the transition wavelengths corresponding to the three-color resonance photoionization of YB174 within an accuracy of plus or minus 30 megahertz, and utilizing this wavelengths, we have optimized the laser intensities and obtained a spectroscopic selectivity of more than 99%. And these wavelengths and intensity values were utilized in the collection experiment to get the product enriched to better than 98% in the chamber, in the actual collection chamber, with a production rate of 3.5 milligrams per hour. Thank you, everyone.
Okay, Seema, you are working on a yttrium isotope 174, isn't it?
Yes, sir.
And it has a maximum abundance.
Yeah.
Then why you want to enrich it? It is already so much, ni? Is it not sufficient?
For getting high purity nuclear radioisotope, the precursor isotope has to be in the enriched form. Towards that purpose, we are enriching this precursor isotope to better values.
No, suppose we use just as a natural abundant.
Yeah.
Natural abundance, samarium. Will it not do the job? Because it's the highest abundance of 174 itself.
So for nuclear medicine, for targeted nuclear medicine therapy, it is in literature it is said that it is the isotopes have to be in pure form, so that when the cell volume is less, the isotope has to be in pure form for medicinal purpose.
The size wise you are gaining factor of 2, but can you think about isotope 168, yttrium 168?
Yes.
Will that have a
Will that have a? Sir?
see yttrium, if when you are going to irradiate in the reactor, the yttrium 168,
Yeah.
that is not desirable, na?
Yeah. That's not desirable.
Yeah. Okay. Nakhate Savri, you good.
Okay, okay. We can go to next.
So our next presenter would be Mr. Atul Charan Sahu from BRC, and poster number is CP0926. Mr. Atul, can you hear us?
Yes.
Please continue.
Good afternoon, all of you. So I will be basically presenting measurement of isotope shift of samarium by two-color three-step photoanalysis technique. Introduction is basically specific isotope of samarium has applications in nuclear and medical industries, and isotope shift data of samarium are important owing to its applications in scientific and technology areas such as trace element analysis and laser isotope separation, etc. And these data are also in interest to study the nuclear properties of atoms. And the isotope shift basically arises due to the difference in mass of the nucleus and the difference in the volume of the nucleus. Next slide. And the left side of the upper part is basically experimental setup in which two n-type of lasers are used to pump two dye lasers, and the dye laser beams are combined and directed inside the atomic chamber where laser atom interacts. Ions are formed due to laser atom interaction, and they are extracted and accelerated by electric field and then travel in drip tube of the time of flight and finally detected in the MCU detector, and the photonic signal is monitored on the DSO and recorded using the data acquisition system, and a part of the beam is passed through the wavelength meter for wavelength acquisition and calibrate the photonic spectra. And this is the schematic of two-color three-step photonic process where first step laser excite the first metastable level population to the first excited level, and further excitation and ionization was done by the another laser. And for measurement of isotope shifts, so we have to record the two-color photonic signal while scanning the laser in the first step or second step. If we want to measure the first step transition isotope shift, then we have to record the photonic signal of those isotopes we want to measure, and while scanning the laser at in the first step. Similarly, for second step transition isotope shift, we have to measure the record the spectra while scanning the lambda 2. Similarly, in the lower part in the left figure is basically two-color photonic spectra of samarium 154 and 50 simultaneously while scanning the laser at 591. Similarly, in the right side figure is basically two-color photonic spectra of samarium 54 and 50 while scanning the laser around lambda 2. So basically, from these peaks difference, we can determine the isotope shift of those isotopes 54 and 50, 154 and 150. The difference between the marks, difference between the peaks will give the transition isotope shift. So we have measured basically for two first step transitions, and these values are well matching with the reported values. And in the second step transition, we have measured for 5 transition for the first time. Next slide.
Next.
Basically, these are the results, and we are tabulated in the table.
Finished.
Thank you.
Okay, Sahu, you tell me, you have got all the isotope shift which you have measured, they are negative, isn't it?
In the second step, negative, but in the first step, both positive and negative.
Okay. First of you tell me whether it is a mass effect or a volume effect in samarium, which is more dominating.
In samarium, volume effect is more dominating.
And from the sign of the isotope shift, can you say something on the configuration?
Yeah, basically whenever transition is occurring from S to P transition, there is basically the change in charge distribution at the nucleus is decreases, hence it basically is isotopy become negative. But when is transition occurring from P to P to D, then due to the screening of the electrons are decreases, hence probability of finding the hence isotopy is positive in case of P to D transition.
And just one more question. Sahu, when you record the spectrum, there's one thing is called integration time constant of your system. Now, how to overcome that? If you want to subtract that you want to rule out that fact, time constant, integration time constant, how you will do that? Have you done it?
Sir, actually, while recording, basically we have to observe the time of flight mass signal, and from the signal we have to set the gate width of the gate boxcar averager, the appropriate delay, so that we can record the signal, so that the noise ratio, signal to noise ratio will be
Agreed. No, to get your signal to noise ratio better, you have to have integration time. How to nullify that? How to reduce its effect? Can you do with your spectrum that recording of the spectrum? Can you do something anyway? Okay, Nakhate ji.
Why 154, 150 only isotopes? Is
Sir,
there any
actually
special
we can measure all isotopes, but here I am showing only 154 and 52. And
why you have chosen that? Why you have chosen? Why there could be a 150 to 154 or something? I don't know. They remember the isotopes, but 150 to 154 is
150 is there, but if isotopy between 50 and 54 will be, if the isotopy between 50 and 54 will be more, then that can be used for selective photoionization of 152. But here I am only showing 54 and 50.
Can this value be extrapolated or interpolated to the other isotopes straight away, or is there any reason it hinders? If 54, 50 is known, then can you extrapolate to 52?
It can be extrapolated, but we have to first measure some transitions. Yeah, we have to calculate the reported values. Then we can extrapolate how much ratio between 52 and 52 and 54 to 152.
Does it changes from the transition to transition, this ratio, or it remains same?
It changes. It is not normally. It is not fixed.
ये सर का नेटवर्क चला गया रे, गोल गोल घूम रहा है.
Okay, I'm through.
Hello, next.
Good afternoon, everybody. The title of my presentation is Measurement of Photonics of Atomic Summary of.
मंडल इको हो रहा है,
इको हो रहा है. Good afternoon. The title of my presentation is Measurement of Photonization Cross-Section of Atomic Area using specially apertured and focused laser beam. Photonization cross-section is important to quantify photonization yield in a multi-step photonization process and to understand plasma behavior. Generally, photonization cross-section from excited state is measured using saturation method. In this method, dependence of photonization signal is studied as a function of photon fluence or pulse energy, and the resultant saturation curve is fitted with the solution of the population rate equations to extract cross-section values. This is true when laser beam profile is spatially uniform or close to it. If it is not, then can be problem. If photonization cross-section is measured with a focused laser beam, we have observed that it gives a lesser cross-section values. So to understand that thing, we have studied. Next slide, please. Using three-step photonization spectroscopy, we have studied a saturation curve for a photonization transition and using unfocused beam and focused laser beam. When laser pulses are temporarily delayed and spatially uniform, in that case, solution of the population rate equation can be written as equation 1. Here, the sigma 3, that is potential cross section of the final step transition, that we are interested to measure. So we have studied the saturation curve for unfocused laser beam that using a fixed aperture size 3 mm. There, the photonization signal as a function of photon frequency is studied, and that experimental data point is fitted with equation 1, and we have obtained a cross section value of 5 into 10 to the power 16 centimeter square. But the same study we have carried out with focused laser beam, and there we have obtained a cross section value of 1.4 into 10 to the power 17, which is significantly lower. Both are for a same photonicity transition. So why is it so? So it could be that equation 1 is not valid for focused laser beam. Next slide, please. To understand that, we have taken that special profile of the ionizing laser beam and using a beam profiler. Pixel size is 4.4 by 4.4 micron. So if we zoom that, so we can see that laser beam profile of that intensity is showing by the color, and it is diameter is 90 micron. And if we see the X and Y profile, that at the center it is intensity is more, but at the wings it is very less. So whenever we are increasing the laser power, so wings will also contribute. To calculate the contribution of wings, we have performed a numerical calculations. So for each pixel data, we have calculated the photonation yield, and we have summed up for each laser energy and we have varied the laser energy that yields the saturation curve. So we have calculated the saturation curve numerically. So in the figure, we see the experimental data point for focused laser beam. Now there are two lines. One is red line, which is the numerically obtained saturation curve, where we have used potential cross section of 5 into 10 to the power 16, that is obtained from apertured beam. So here the cross section value obtained from apertured beam is that numerical saturation curve is matching with the experimental data of the focused laser beam. That means the whatever wings effect, that is already taken care by the numerical code. And we have also performed the numerical calculation for that another value, that 1.4 into 10 to the 17, that is new one. It is not matching. So want to measure the potential cross section using
Okay.
need to do numerical calculations. For your kind attention. Over. Yes, sir. It's over. It's over, sir.
Okay, Mandal.
Yes, sir.
You tell me this saturation method, measuring a cross section by saturation method.
Yes, sir.
Bing's effect is known. It is, isn't it? It is known. But
sir,
in how way you?
Generally, it is uniform beam is preferred.
Okay.
If there in the wings there is a excitation,
Uh-huh.
then it will be significant defect. If it is excitation is negligible compared to the central part of the laser beam, then it will be insignificant defect. If it is wings contribution is insignificant. In this case, the focused laser beam diameter is 19 micron, but the excitation laser beam diameter is much larger compared to that.
Suppose the ionizing laser, if I take the central part of that,
yes, sir,
flat part, and then I focus it, then what will happen?
Again, it will be a Gaussian beam. Whenever we focus, it will be a Gaussian beam, so there will be wings effect.
Nikhatte ji, Savri ji.
Normally, when we measure photoionization cross sections, is it advisable to use a focused beam? I mean, what are the advantages of using focused beam?
Focused only one advantage, it gives the higher energy density. but at the same time we have to control the wings excitation. If it is not, then it may lead to wrong result.
Proceed. Nakhareji,
Yes, okay. Yeah.
Okay. So our next presenter is Dr. Sudarshan Baruaji from BRC, and his poster number is CP0928.
Good
Dr.
afternoon,
Barua, can you
everyone.
hear us?
Yes. Can you hear
Please
me?
continue.
Good afternoon. This presentation is about Doppler width reduction of an atomic vapor beam by means of geometrical collimation in the field of laser isotope separation for ytterbium-176 isotope. As we have already heard, lutetium-177 isotope is a very important radioisotope used for diagnosis and treatment of various types of cancers. Since this is a synthetic isotope, there are two main routes for production of this isotope: neutron irradiation of natural or enriched lutetium-176, and secondly, neutron irradiation of enriched ytterbium-176. In the first, or the direct production route, the neutron reaction cross-section is about 1000 times higher than the second one. But the chemical separation of the product, that is lutetium-177, from the target material, lutetium-176, is difficult as they belong to the same element. On the other hand, the indirect method, that is the second method, has the advantage of no carrier-added chemical separation. For both these two production routes, enrichment of the input material is necessary. And one of the methods for enriching the input material is the laser isotope separation method. For the indirect route of production, that's the second one, the isotopic purity of YB176, ytterbium-176, has to be better than 95%. This implies that the Doppler rates of the ytterbium atomic vapor beam in the LIS method has to be very less, so that the nearby isotopes are not ionized in the selective laser ionization process for ytterbium-176 isotope. Next slide, please. The Doppler width of a propagating atomic beam depends on the divergence of the atomic beam in the direction of the laser propagation. This divergence, if this divergence can be reduced, then the Doppler width naturally of the beam can naturally be reduced. This can be done by implementing a collimating structure above the crucible, which is the source of our atomic vapor beam. This collimating structure has been named the Doppler reducer here, and it reduces the geometrical divergence half angle from 41 degree to 18 degree. Next slide, please. To see the effect of the Doppler reducer, ytterbium vapor flux was measured at the height of the laser atom interaction zone. The measured as well as the simulated plots for the vapor flux without and with the Doppler reducer can be seen in the left side of the slide. The simulation is done using the direct simulation Monte Carlo code, popularly known as the DSMC code. And the right side shows the simulated profiles of the velocities in the laser propagation direction. From the velocity profiles, it is evident that the width of the profile has reduced significantly. Consequently, the Doppler.
What happened? Hello.
Baruaji, can you hear us? We are not able to hear you. Vasdev sir, can you hear me?
Yeah, I can hear you. But
Okay, but
what happened?
Baruaji, maybe network issue.
Mm-hmm.
We are not able to hear him anymore.
Baruaji?
So shall we move?
Okay, what can we do now? Na?
Okay.
Yeah, we can move to the next speaker.
So next is
We can move to the next question. Maybe we can come back if it is required.
कौन है next? Okay. So next presenter is Dr. Siu Mukund from BRC, and the poster number is CP0929.
Okay.
Mr. Siu, can you start?
Am I audible?
Yes, yes. Please go. Go ahead.
Okay, thank you, Sandeep. Good afternoon to everyone. I am presenting my ongoing research work on laser spectroscopy of vanadium fluoride molecule. In general, the study of transition metal containing diatomics have importance for gaining understanding of larger molecular system and to test validity of benchmark ab initio quantum mechanical methods. So in that way, while halides, carbides, nitrides, and oxides of many transition metal are well characterized, few metal halides have been studied so far. On the VF molecule, very limited spectroscopic data is available, and only 2 experimental and 2 theoretical work have been reported so far, with ambiguous verdict on the symmetry of the ground state of vanadium fluoride molecule. So a recent experiment by Burnett proposed that the ground state is doublet delta. However, they did not rule out the possibility of doublet pi ground state. Thereafter, theoretical calculation by Mavedres proposed just opposite, that pentate pi is the ground state, while a doublet delta is the first low-lying state. So unambiguous assignment of the symmetry of the ground state and also determination of its spin orbit splitting or separation motivate us to take the present study. So we present our first observation of the separation of 2 of the first 5 spin orbit components and vibrational frequencies of the unambiguous ground state of VF molecule. Please, next slide. So this is the schematic of the experimental setup of the supersonic molecular beam, which is an excellent source to produce translationally cooled atoms, exotic molecules, and clusters of refractory natures. This setup utilizes laser vaporization in conjunction with supersonic expansion to produce cooled beam of species in this beam. In the first chamber, we study the free jet, and in the second chamber, a time of flight mass spectrometer is installed to study the photoionization studies. And next slide, please. So we perform a survey scan, and a few electronic states were detected in the region of 14,400 to 15,000 wave number region. And a DF spectrum is shown on the left side by exciting a single rotational line from one of the observed excited electronic state in this region. And we have got vibrational frequencies up to equal to 5 in the ground state, from which we have determined the vibrational frequencies like 669 wave number and n-harmonicity 7.3 wave number. Apart from this, we have seen in other DF this separation of another spin orbit component, which is of the order of 70 wave number. So further study is in progress to establish the symmetry and spin orbit splitting for the ground state in the excitation LIF spectra. Thank you.
See, as I understand, this molecule, the atomic molecule, it is as such doesn't exist in the nature, isn't it? But still, you people have synthesized that, right?
Yes, it is a transient species produced in the beam.
Produced in the beam. So finally,
collision-led atmosphere. So it may not have reacted with bigger molecules. So it is in that atomic form. Which is
okay. Now you did that study. What is the finding of your study? I mean, what from these studies? What you have actually? What are the findings of your study? Highlights of your study?
Yeah, actually, as I have shown in the introduction part, there is an ambiguity in the determination of the ground state, which is very important in the determination of the chemical reactions and dynamics of the molecules.
Okay.
So in that that have also importance in the catalytic process, considering the transition metal elements. So in that sense, it is very important to establish, and as well as I have also mentioned the theoretical calculations. So they also contradict the observation by or the proposed work of the the experimental proposed work. They also telling that. So to establish the ground state symmetry is very important, which is to determine the validity of the ab initio calculation as well as the spectroscopic parameter which is deduced from the our study is useful in that process also.
Okay, Sabri, you want to ask anything?
Yeah, so actually, I would continue with your question. So the ambiguity in the ground state, has it been removed with your study?
This is in process. We have recorded some of the excitation spectra and analysis in this progress. So we definitely we can do that. We are going in that direction.
Okay, so in one of the states you have characterized for spin orbit components, right?
Yeah, ground state we have observed the spin orbit, but it is only two component was observed in the DF spectra. But we have seen a lot of excitation spectra. By analyzing that, we can get the information about other spin orbit is splitting for the state.
Okay, thank you.
दिखाते जी नहीं ठीक है okay, thank you Shiva.
Yeah, thank you, sir.
So our next presenter is
But it is over, not 29.
Some of them joined. No, actually some of them have joined later, sir.
Okay.
So our next poster is CP0910,
Okay.
Miss Aarti Jaiswal.
Yes, sir. I am audible, sir.
Yes, continue.
Okay, good afternoon, everyone. Today, I am presenting my paper that is fast detection of chromium 3 and molybdenum 6 ions in the aqueous medium by colorimetry and surface enhanced Raman scattering using vanillic acid functionalized silver nanoparticles. In this paper, we know that these days metal ions have very challenging issue for the modern society due to its extremely toxic, non-biodegradable, and bioaccumulative nature of the heavy metals in the ecological system. And there are many conventional methods of the detection of heavy metals like cold vapor atomic fluorescence, atomic emission spectroscopy, atomic absorption techniques, operating many tough ingredients and having consuming with involvement of trained manpower with specialized knowledge, increasing the overall cost of operation. Therefore, functionalized plasmonic nanomaterials have been used for enhancing the Raman scattering across the metal ions of many order of magnitudes, enabling their specific and selective detection. The plasmonics, the phenomenon is called the surface enhanced Raman scattering, which we call the SERS. It is now being used for high specific and ultra sensitive detection of the analytes present either sorry present in traces. SER utilizes the strong electromagnetic field enhanced created by the excitation of plasmonic nanoparticles upon the exposure of the radiation to magnify the Raman signals to the analytes placed in the close proximity of the nanoparticles. Next slide, please. Next slide. Okay, this is the synthesis method. Here we use the vanillic acid functionalized silver nanoparticle. We have synthesized with the use of the sodium borohydrate as well reducing agent. Firstly, we prepare 3 solutions: 10 ml of 5 millimole of silver nitrate solution, 30 ml of 10 millimole of NaBH4 solution, and 5 ml of 1 millimole of vanillic acid solution were freshly prepared in distilled waters. Now, the solution of silver nitrate and vanillic acid solution were mixed homogeneously on the magnetic stir. You can see here in the diagram for the 5 minutes, and the resultant solution was added drop by drop in the solution. Borohydrate solution kept in ice bath in the dark under the constant stirring, and instant the color solution turns black, indicating the formation of the silver nanoparticles. Here you can see the UV visible spectrum of the functionalized silver nanoparticle with vanillic acid and Raman spectrum also. Here The UV visible, the recorded spectrum of the UV visible ranges is at 392 nanometers. The position of these band gaps, the correction estimated by the size of the the size of the nanoparticle in the present study at the SPR band at 392 nanometers. In the Raman bands, we can have a many peaks at 232 centimeter inverse carboxylate groups, 361 centimeter inverse ring twisting vibration at 421 centimeter inverse ring twisting, 485, 641, 779 and 724 centimeter inverse indicating the vanillic acid ring deformations and so on. And please next slide please. Yeah. This was the colorimetry changes. So in previous slide there was the colorimetric changes also, and after we recorded the UV visible spectrum for detecting the how this nanoparticle interact with the metals ions and what were the changes we can see here and there also. Here we can detect two metal ions, chromium third and molybdenum sixth. You can see here that the Raman spectrum of the solution of vanillic acid functionalized silver nanoparticles plus water sample containing different concentration of chromium ions and also different concentration of molybdenum sixth ions. Plot the concentration of chromium ions in the water versus the intensity of Raman band at 244. You can see here that 244 centimeter inverse and at 870 inverse of molybdenum 6. And we can see here that we can see here that initially at concentration increases, the Raman signal will also be increases. Okay, thank you, sir.
Okay, Aarti, what type of light source you have used in this study?
Sorry, sir. Once again, sir, please.
What is the light source you have used in these studies?
Sir, I am using the 785 laser sources. 785 laser for Raman, and for UV we have used a tungsten laser beam.
Okay.
Yes, sir.
Dikhate, Sabri,
There is
anybody?
a determination of this probably chromium or something. Initially there is a linearity and then it decreases,
Yes,
drops
sir.
down.
Yes,
Why?
sir. Yes,
There
sir.
should be, can it be used?
Sir, actually, it depends upon the concentration. So initially stages when we actually we fix the amount of the synthesized silver nanoparticle which can be functionalized by vanillic acid, but we have different concentrations of the metal ions. So after certain amount of metal ions, this order will be distracted because I think. डैट्स कॉम्बिनेशन विच भी मतलब डैट सर मैं हिंदी में बोल दूँ मतलब सर जो हम लोग को एक कॉम्बिनेशन टाइप का मिलता है मतलब बनाने के बाद में वो वहाँ पे सर उस लेवल का नहीं होता है कि हमारा सर्च उसे डिटेक्ट कर पाए, तो इस वजह से वहाँ पे वो उस मतलब वो इंक्रीज ना होकर के डिक्रीजिंग ऑर्डर में मतलब जाने लगती है उसकी
What is the motivation of this work? To determine the concentration, right?
यस सर फॉर एक्चुअली सर हम इसमें लिमिट ऑफ डिटेक्शन एंड लिमिट ऑफ क्वांटिफिकेशंस भी निकालते हैं सर, तो ये उस
But then when it is decreasing, you don't know whether it is at a lower concentration or higher concentration, because you will get the two concentrations at the same light intensity, right? Signal.
Yes, sir.
There will be ambiguity whether it is a low concentration side, linear side, or the other side of the graph.
Falling side.
How do we decipher that?
सर एक्चुअली इट इज नॉट फिक्स्ड कि ये इनिशियल कंसंट्रेशन में ही किस में चेंज होगा, किसी में हायर कंसंट्रेशन में चेंज होगा, तो सर ये तो हम जब चेक करते हैं तो ही पता चल पाता है हमें.
Okay, we can.
ठीक है.
थैंक यू सर.
Thank you. Okay.
एक मिनट. Next presenter is Ashwini Kumar Patnaik from IIT Kharagpur, and poster number is CP0912.
Hello. Yeah, am I audible?
Yes.
Yeah. Hello. Good afternoon, everyone. I am A.K. Vatnaik. I'm from IIT Kharagpur. Today I am going to give my presentation on enhancement of defect peak in WSC2 under two-state light excitation. So before going to this two-state light and WSC2, I just want to draw the attention at why we are interested in these fields. So after discovery of graphene, the 2D material field is drawing great attention of the people due to exciting physics. But we know that the graphene has no band gap. So for the optoelectronics point of application, it is not a suitable material. So this TMDC material, they are coming up to the front. And this TMDC material has a very exciting property, that is the Valley physics property, that with addition to spin of the electron, we have addition degrees of freedom, that is Valley. And another interesting material of this TMDC material is that these are direct band gap semiconductor at K and K prime point. Most of the semiconductor, we have that band gap near gamma point. And we know that these are 2D materials, so due to this 2D confinement, the binding energy of the exciton is very high. So for that thing, we have very stable excitons. And another thing that due to the heavier transition metal, here I can show you one example of TMDC, that is WSC2. W is a transition metal and AC is a chalcogenase. Due to this heavier transition metal, we have strong spin orbit coupling. So what it does, it leaves the degeneracy of conduction band and valence band. So valence band and conduction band are splitted. So this leads to the separation of dark and bright exciton states. In the next slide, I will come to the bright and dark exciton states. But here, I just want to draw your attention that here in the left-hand side, we have shown you the picture of a WSC2 flake, and the highlighted point, you can see this is the monolayer. And from this monolayer, we have taken the spectrum, the PL spectrum. In the right-hand side, we have presented at the room temperature spectrum. This is the bright exciton. You can see that we are getting very high bright exciton, that is up to 700 arbitrary unit, and in the middle one, it is at the 3.2 Kelvin it has been performed. And you can see that the bright exciton peak, that is arising at 1.75, it is a bright exciton, and it has very low intensity. So can you go to the next slide? So what happens, these kind of exciton, bright and dark exciton, these are differentiated due to their orientation of the dipoles. Bright exciton are in-plane dipoles and dark exciton are outer-plane dipoles. So by using a transverse field, we can excite the bright exciton, and the dark exciton can be excited by using a out-of-field dipole, that is EZ field. So we have utilized a vortex beam, because with increasing charge of the vortex beam, we can increase the EZ field. So what is a vortex beam? Vortex beam are the helical structure phase beams which are known to carry orbital angular momentum that can be from early integer order. So by using a SLM and a computer generated hologram, we have produced our vortex beam, and this vortex beam has been used to excite these excitons, that is the outer plane dark exciton. And with increase here in the simulation part, you can see that with increase in charge, topological charge number of the vortex beam, the EZ phase is increasing, which changes the, okay. So, okay, I don't have more time, so it will take long time. Thank you.
Hello, Mr. Patnaik.
Yes, sir.
Yeah. You said that enhancement of that band, that this thing now by the twisted light, isn't it?
Yes, sir.
In how exactly it is important? Why it is so important to study this particular thing?
Yeah, actually, these defects peak, those are not up to now. It is not, people are not sure that what are these defects peak, because recently we know that those defect peak that we are talking about, these are some dark exciton replica peak. Means there are phonon modes available in the system, and these phonons interact with the dark exciton, and they give rise to this dark exciton replica, and the most of the peak, those comes under the dark exciton replica. So if we are using vortex beam, we are using the increasing the EZ field, and those particular peak which we get sharp increase, so those basically comes from the dark exciton replica peak. So it is not like that those all our peaks are from the replica, means all are from the defects. Lot of peaks are coming from the dark exciton. So our main aim is that to emphasize this factor, that using the EZ field, we can increase the dark exciton, and the rest of the spectrum which is not well understood, those are some phonon replica of the dark exciton.
Okay. दिखाते जी सावरी.
Okay. Your study proved that the dark excitons exist there. Means from the study you could infer that there is
the dark exciton exists in this material. And our study also emphasizes that okay, there is dark exciton in the material. Even if by using a transverse field, means by using in a vertical excitation, we can excite the dark exciton. Why? Because we are using this material size of sub micron order, and we are using some 0.7 numerical aperture objective. So we are definitely have EZ component in our normal excitation instead of using a vortex beam. So
this is particular to this compound, or it exists everywhere basically. So this is a WSE2.
No, actually, yeah, this kind of dark exciton, it exists in TND's material. It exists in MOS2, WS2, MOS2.
Yeah, MOS2. Yeah.
But we are interested in WS2. Why? Because in MOS2, the peak, that dark exciton band, it exists in the upper band. So at low temperature, the oscillator strength is very less and the binding energy is less. So at higher temperature, it is difficult to probe because the number of dark exciton available in the case of MO and MO based material is very less. So W.
I think.
Okay, we can go ahead now. Okay.
Okay.
Next.
Okay. Next presenter is Aparna Tiwari. Poster number is CP0914.
14. Sir, am I audible, sir?
A little louder, please.
Okay, sir. Myself,
Continue.
Aparna Tiwari. Myself, Aparna Tiwari, is going to present on the topic from and non-destructive assessment of the pigment of water calotropes by laser-induced fluorescence spectroscopy. Here we have used laser-induced fluorescence spectroscopy in order to investigate the spectral signature, which is a quite popular tool in biological science as due to its non-destructive, non-invasive, and non-rapid and robust technique. The natural next is the natural pigments that is present in various parts of the plants like stalks, leaves, flowers, fruits, etc. are found to play an important role in the plant's growth as well as beneficial for human health, as they are also being used for various industries like food industry, textile industry, pharmaceutical industry, horticulture, floriculture, etc. Nowadays, the demand for natural foods are increasing as they are beneficial for the human health, contamination, and as they are contamination free and also reduces the various epidemic and cardiovascular diseases. In this, one such fruit is water calotropes, as it is a good source of energy, gluten-free, low in sodium, and high in potassium. It also contains rich amount of minerals like calcium, zinc, minerals, iron, and phosphorus. It is also rich in polyphenolic and flavonoids, and thus possesses antiviral, antioxidant, and antiviral properties. These all properties of water calotropes are attributed due to the presence of various biochemicals present in it. Sir, please, can I see my next slide? A violet diode laser of wavelength. A violet diode laser has been used having wavelength of 405 nanometer and having power 50 milliwatts, which was used to excite the sample, and the sample was kept at 50 centimeters away from the laser source in order to avoid the photo damage. And the fluorescence signal was collected with the help of the optical fibers having diameter 600 micrometers. The fluorescent signal was then fed into the entrance plate of Avatar software and recorded in the spectral region of 400 to 800 nanometers at a resolution of 2.3 nanometer. And then the acquired spectral data were exported to Origin Pro 9.0 software package for further baseline correction, smoothing, and peaking peak. Next slide, please. In this figure, the recorded laser-induced fluorescence spectrum of the exocarp and mesocarp portion of green and red variety of water calotropes are shown here. The exocarp portion of both the varieties depict a strong band at 684 nanometers, having a shoulder at 747 nanometers. This band denotes the presence of chlorophyll, while in the mesocarp part of both the varieties, chlorophyll bands are shifted and observed at 680 nanometer having a shoulder of 732 nanometer. In both the exocarbs and mesocarbs of green variety of water calotropes having the chlorophyll band at higher intensity as compared to the mesocarp and exocarp of red calotropes. Along with this, in the mesocarp part, there is a weak fluorescence
Please
signal at,
try to wind up fast.
yes, sir, yes, sir. There is a weak fluorescence signal at 630 and 625 nanometer, which shows the occurrence of anthocyanin. Anthocyanin are responsible for the red color of water calotropes and also belongs to the class of flavonoids. Thus, we conclude that the laser-induced fluorescence spectroscopy is non-destructive, non-invasive extraction-free rapid detection technique for the semi-quantitative analysis of the pigments present in different foods. Thank you.
I think this we conclude also, ni?
I have just one question. When
Yeah.
you said that exocarp and mesocarp region of caltrope was used. So exactly which region? I just want to know.
Ma'am, I mean to say we have taken two types of water calotropes that are green and red. And in this, we have detected that the chlorophyll amount is greater in the green calotropes as compared to the red calotropes. And one thing also that the anthocyanin band is seen in the mesocarp of both the varieties, but the intensity of anthocyanin band is greater in red calotropes as compared to green water calotropes.
But which part of the fruit you have used for getting your data?
Ma'am, I have used both the exocarp and the mesocarp part of both the varieties.
What is the basically conclusion of your study? Is the chlorophyll will be there, we can see it visibly also in the green one. In the red one, there will be a deficiency, right? So what is the conclusion of your study?
We can, as there are many varieties of water calotropes, so we can say that as the chlorophyll amount is greater than in green.
That we can see visually also. That we can tell visually also.
I think
Khataji. Along with that, there is a addition of anthocyanin band also, which can be seen in red calotrop more than the green water calotrop.
Okay.
Okay, thank you very
Which
much.
can be used in.
So our next and last presenter is
thank you, boss.
SK Amisthan, IIT Madras, and the poster number is CP0918.
Good evening all. I am Amirdan from IIT Madras, here to present on the topic adopting a laser-induced breakdown spectroscopy to monitor the aging marker for pressboard material. Transformer forms heart of the power system network. Insulation must be monitored in the timely basis to find the failure mechanism of the system. Mineral oil has been used in transformer since a century. There has been many additives which are added to the transformer insulation as antioxidants such as DBDS for the better performance. Can you move to the next page? However, it ended up leading in the corrosion of winding with sulfur compound and forming copper sulfate solution in the insulation fluid. It is one of the main threat for the failure of the system. So in the present study, the sulfur concentration is monitored by adopting laser-induced breakdown spectroscopy with a laser of neodymium with 1064 nanometer wavelength. Of the previous slide. Excuse me. Can you go to the previous slide? One figure area. Here, figure 1 shows the spectra of the OIP material of aged and unaged pressboards. Presence of elements like carbon, copper, and sulfur are found dominant with various intensity with the different materials. Based on the LIPS parameters, they are formulated as the ratio. Next slide. Based on the ellipse parameter, they are formulated as the ratio of the intensity of the function of aging period to the relative unaged specimen. A reference ellipse spectra is taken from a failed transformer, actually a field transformer, which shows a ellipse parameter of 50%, below which it is considered as the end lifetime of the pressboard material. Here in the figure, the virgin aged material showed 1020 hours, which is the end lifetime of the, with the addition of DBDS of different concentration, that is 500 and 1000, there is a reduction observed. Also, principal compound analysis is done to lip spectrum for the classification, and a variance of 99.7% is achieved. Hereby, this methodology is one of the effective way of condition monitoring the degradational status of insulation in power transformers. Thank you.
Hello.
Sir.
Yeah. With this study, can we predict the failure of the insulation? Can we predict?
Yes, sir. We can predict, sir. Actually, we have taken a few pressboard material from the failed transformer, which showed 50% in ellipse parameters. So below which it can be considered as a failure, or relative number can be used in order to find the degradational status of the transformer pressboards.
Okay. Dikhate ji, Sabri.
This is the in situ analysis you can do with the working transformer. Is online, or is it you have to take a material and then?
Yes, sir. This is we are at the starting stage, sir. Actually, we have not tried online. We have removed pressboards from the field transformers. Then we have done the analysis in laboratory conditions.
Okay. Okay.
It means once it has failed, then you have taken it out and study, isn't it?
No, sir. Actually, for reference, we have taken, sir, from a failed transformer. But with the operation also, we have taken few transformer specimen, and then we have calculated the ellipse parameters.
Okay.
Okay, thank you.
Okay.
Thank you.
Thank you. Thank you.
So all presenters are over now, and so we thank all our esteemed judges for evaluating the posters in this session, and we would also like to thank all our presenters for their active participation and presenting their work in NLS-30. So now we will break for a tea and return back for the next session.
Sandeep.
Yes, sir.
So when we are going to say, make this list and this thing, Nakhate ji, Sabri.
Sir, I think you can continue in a voice call.
I will suggest that Dr. Vasudev will suggest that we stop here.
Okay.
And after some time we reconnect again.
Or we can talk to each other on the phone itself.
Yes.
We can put it in the voice loudspeaker, and we can talk.
Okay. ठीक है ना. Okay.
Okay, sir. Okay, sir. Thank you very much, everybody.
Thank you.
It was a very long, tiring day today.
I was happy in between the things. We will finish before time, but then many more people came afterward.
Yes, sir. Yes.
Okay, thank you निखाते जी.
सर आप कल आने वाले हैं क्या सर इधर?
मैं इधर से नहीं, वैसे नो आई एम ऑल राइट.
देन आप आइए ना कल इधर.
तो उधर से पढ़ सकता हूँ ना उनका?
हाँ.
Okay. Is it possible to read that biodata from there itself?
हाँ, it is possible. हमारे पास प्रिंट आउट रहता है.
अच्छा नहीं, मैं तो प्रिंट करके रखा है.
हाँ आइए वो सब डिस्प्ले होता है.
Okay.
तो आप आइए कल, यही से करिए.
ठीक है, I'll try to come. I'll come.
Okay, sir.
What time? 9:15 I should reach there, नहीं?
9:15. हाँ, yes sir. 9:15.
9:15 because 10 minutes.
आपका पहला ही सेशन है ना?
Right यार.
9:15 आ जाइए.
और कैसे हो रितन? तुम्हारा अच्छा चल रहा है यार. It is very good, really. No, I was wondering कि will be difficult managing ना ऐसे.
राइट
online, but I think so far it is going on nicely, isn't it?
हाँ स्मूथली चल रहा है, स्मूथली
Yeah,
चल रहा है,
good,
अच्छे
good.
लोग अच्छे काफी हेल्प कर रहे हैं.
Yes, yes.
ठीक है सर,
ठीक है,
ओके
कल मिलते फिर हैं.
ओके ओके सर,
Okay,
बाय, थैंक यू.
okay.